Hey, friends. I was really hoping that I would start playing like right when the stream went live, and I think I timed it okay. Hello, my name is Will. I'm going to give myself like a more formal introduction in a few minutes, but I am super excited to do this machine learning track session, Intro to Python. We will talk about like exactly who this is tailored for, but the short answer is that wherever you are at, it is tailored for you. And I'm going to try to watch the chat really closely, and if things are moving too fast or not fast enough, hopefully I can hear that and we can kind of dial into where everybody is at. And so this is actually my first question is, y'all folks who are here a little bit early, can you drop in the chat like what your experience with Python is? Have you like never heard of it? Have you played around with it? Are you like a Python pro and you're just coming here to hang out? That's also great. But yeah, drop in the chat kind of, if you want, actually, maybe we can do like a 1 to 3 scale where like 1 is total newbie, 2 is like you've used Python a little bit, and 3 is you're a Python pro. You could drop 1, 2, or 3 in the chat. But it's super good to see all of y'all. Oh, so many comments. This is great. I'm glad you like the kalimba. Hello. Here's the thing. I try to call out people's names, but then like usernames usually are not actually like pronounceable names, Atul, maybe. That probably is somebody's name. Okay, we got a lot of 1s and 2s. That is great. Someone's an intermediate. Awesome. Atul is good at Python but wants to learn about machine learning more. That's great. Okay, incredible. Well, so far it looks like everybody is in an excellent spot. I'm gonna see if I can find some slides. I came prepared, y'all. I have slides. We'll only look at slides for like the first 3 minutes, so don't worry. Then we'll actually get our hands dirty. Where are my slides? Oh, here we go. Here we go. Okay, now I get to share my screen. No, like I literally have 3 slides, and one of them is just my face on a screen, which my face is already on a screen, so I don't even know I have that slide. Don't despair. Oh boy, y'all. I got a new computer and all the permissions are reset, and Google did not have access to see my screen. This could be bad. It's telling me I have to quit and reopen to share my screen, which I actually like really have to do that. So we're actually going to pause the stream for a second, and I will be back very, very soon. I appreciate all the empathy. Okay. Hopefully that wasn't too long, and hopefully I can actually share my screen now. Yeah, y'all waiting. I appreciate everybody being so patient for those 30 seconds. Let's see. And now I can share a screen. Incredible. Okay. Oh, thank you for the compliments on my camera. Yeah, it's the Sony A7C. A couple months ago, Google, where I work, they said, hey, here's $1,000 to like upgrade your work from home setup. And I was like, dang, okay, I could spend this all on a camera if I also use it for video calls. And they were like, yeah, that's fine. And so I got to buy a camera. Okay, incredible. Why don't we also in the chat, I want to give just another few minutes for people to trickle in. In the chat, tell me where you are calling in from or viewing from and what the weather's like. I am based in Seattle right now, and it is actually really sunny. I had to put down my curtain because it was actually causing a lot of backlighting. And I am nothing if not obsessed with my lighting. Okay, so we will kick off. So this is Intro to Python, which is the first session in the Build a Machine Learning Web App track. I guess we're calling it a track is the thing. So my name is Will. I am, as I mentioned, a software engineer at Google. I am also a coach at Major League Hacking. I am a big Python enthusiast. And one fun fact about me, which we will actually touch on more later, is I am unbelievably caffeinated right now. And I really, really love coffee. I'm a big coffee fan. In fact, we're doing a coffee mini event on Tuesday, which I would love for everybody here to come hang out with me at. Okay. Folks in India, mad respect, y'all tuning in at 2:30 a.m. I cannot believe it, but I'm honored that you're here. Lots of folks having cold weather, which I send my best wishes. Okay, so this is kind of the zoomed out version of this whole track. Today we're doing Intro to Python, but the goal of this track is really to show you kind of from beginning to end how to tackle a machine learning problem and actually deploy a solution, right? I think that there's a lot of machine learning content out there that's like, here's how to do this one very math-focused thing. And then there's also stuff out there that's like, hey, like here's how to build a web app. But I really, really wanted to bring these things together and say, here's kind of the whole process of thinking about your problem, going and finding data, exploring your data, building a model, testing a model, and then actually putting that on the web so people can use it. So I am not sure if this is in any of the descriptions, but the project that we're going to be building up to is building a web app where you can enter in information about a house and it will predict the price of that house. It will predict how much that house is going to sell for. I recently just bought a house and it was like a nightmare, but it was a thing that I thought about a lot for a while. And so it's something that's been stewing in my brain. And I thought, hey, this is like a real problem that I actually could fix with some machine learning. And so that's kind of the grounding there. So this is the last slide. As I promised, there aren't that many slides. We're going to get our hands dirty very quickly. So this is Intro to Python. I wanted to give a little bit of a heads up for what we're actually doing. So we saw a lot of 1s and 2s, which is perfect. I will just put out front that if you have never programmed at all, this might be actually a pretty quick introduction. And if you've never programmed at all, that is still cool. I am thrilled to have you here. But I'll say that if you have either written a little bit of Python or programmed in another language, then this is going to be perfect for you. If you've never programmed before, please stay. You are super welcome. We will answer all of your questions. But I just want to warn you that it is going to move kind of fast if you have never programmed before. So the big things that we're going to look at today, we're going to look at, actually, before any of this, we're going to look at this tool called Google Colab, which is super useful and will help us actually explore stuff. And then we're going to dive into Python and look at variables. We'll look at lists and dictionaries. We'll look at ifs and loops and control flow. We'll look at writing functions. And then finally, the big thing we're building to is to look at libraries and specifically dive into this library called Pandas, which is really, really a great and big and complex library that we're going to try to use. I see some folks asking about like what even is machine learning. And I will say that I will do a few seconds on that, but I will say that we will get kind of really deep into actual machine learning in all of our other sessions. This session really is an intro to Python, but the basic idea here is that we want to build something. We want to build an artificially intelligent algorithm that can look at data and can use that data to predict things into the future. Someone's asking if I will be in all of the sessions, and yes, I will. I will be in this session, and then I believe we have the next one on Wednesday. And then after that, I believe it's Friday and then Saturday. And I am really psyched for all of them. This one is great. I love Python, but I'm like really, really psyched about the other three because that is when we'll really get into it. Someone's asking how long the session will be, and we should run about 2 hours. I tried timing myself once, but you know it's always different when you are actually talking to the world. So we'll see. But without further ado, I'm like allergic to slides, and so I want to get out of them as soon as possible. We're going to nix that, and I am going to frantically pull up my notes so I can have all of my links handy to send to you. Whoop. You don't get to see those. Those are for me. Someone said that I could Maybe they're saying I could play Spider-Man, and if that is to say that I look like Tom Holland, that might be the best compliment anyone could ever give me. So thank you, if that is in fact what you mean, which I will assume it is, because that's good for me. Okay, so for starters, I mentioned this tool called Google Colab, and that is the tool that we're going to be using for the first 3 sessions. We're going to exist mostly in Google Colab. And let me see, we probably need to get this a little bit bigger. That's looking probably legible, but let me know if you're like, Will, I can't read this. I will say this is basically Google's version of a tool called Jupyter Notebook. If you have that locally, you are more than welcome to use that. I'm using Google Colab because this is something that everybody can just jump into and will have the exact same sort of environment. I think there's a lot of value in my screen looking exactly like your screen. But if you want to do something locally, if you know what you're doing, be my guest. So you should see a screen that looks pretty similar to this. It might look a little bit emptier, which is totally fine. But the first thing that we want to do, I've prepared a little notebook for us. I will drop the link to that. Now, if you want to go to this link, you can see sort of the raw repo that's pretty barren right now. But the important thing is to take that link, paste it in right here, hit search, and then you should see something that says Part 1, Intro to Python, and you can click on that. Aw, I thank you for loving my energy. It's good to hear. Like I said, heavily caffeinated, that's what I do it for. Okay. So this is a notebook. A Colab notebook is really the same thing as a Jupyter notebook. But the key here is that we have these individual cells that have code inside of them. And the reason that this is really nice is because when we're doing research, when we're doing machine learning research or artificial intelligence research or data science, we are exploring, right? We're playing with data, we're seeing what we can do, and we're not necessarily building like a production-ready app. And this is something that I want to drive home, is that notebooks are an excellent tool when you are just starting out to play with your data. But this is not like where you're going to write your production web app, right? We're actually going to switch to a different set of tools for that in our last session. But notebooks are really, really great because you can take one chunk of code, run it, and then change it and run it again. And that's a really, really sort of helpful toolkit for us to play with our data. So hopefully you're at this place now. If you are not, just remember to open this, click on GitHub, and then drop that GitHub link in there, and then click on Intro to Python for Machine Learning. Okay, so a quick intro to Colab or Jupyter Notebooks if you're using that. We have these individual cells, and each of them have a little play button. And if we press this play button, this will actually run all of the code inside this cell. We'll talk about all the code. It'll give you this little warning at first, and you can just say run anyway. What's really cool about this, especially in Colab, is you could be on any computer, and actually, when you press play, you send this off to one of Google's servers, and they run that bit of code for you, and they send you back the results. So let's get some free computing power from Google, right? So we have individual cells. We can run them individually. Another thing to be aware of is sometimes we'll write code in a cell that will just take way too long to run. And if we do that, if we get stuck on running, then we can go up to runtime and we can click interrupt execution. Usually we'll try to avoid that, but if you do get stuck and you say it's not returning, then you can try to exit the runtime or interrupt the runtime and then fix whatever was taking a long time to load. I will say on your first run, it may actually take a minute. It has to dust off all the cobwebs if you haven't done this before. Also, thank you for helping resending links to folks that have missed some of the links. I will drop the 2 links again just to make sure everybody has them. So we are all syncing up on Google Colab. When you get to Colab, you're going to want to hit the GitHub tab when you open a new notebook. And then in there, there'll be a search bar. And you want to drop this GitHub repo into that search bar, and then click to the one thing that should show up. It'll be like Part 1, Intro to Python. So without further ado, we are hopefully now all kind of set up in our environments. Either you're in a Jupyter Notebook or you are here with me in Google Colab, and we can actually start exploring Python. And I think that Colab is a great tool for exploring a new language because of the way it lets you play with things. As we go through, first, please ask questions if you have them. Second, feel free to mess with the variables and mess with what are in each of these cells. That's the whole point of it. I think one of the best ways to learn something is to see if you can break it, right? And then after you break it, see if you can maybe fix it in a new way. But so to start off, central to Python is this idea of variables. We can create a variable by typing out a name using the equal sign, which is the assignment operator in Python, and then putting a value in it. So for example, here we're creating a variable called myInteger, and we're putting the number 6 in that variable. So myInteger now refers to 6. We can also do floating point numbers just by saying, 16.5, or we could say 16.4. We can use strings, so we just use single quotes, or you can use double quotes, but I use single quotes and then write our text. That's going to go into a variable. And then finally, we can store Booleans, which are just true or false. I see a request for explaining notebooks. Really, the only thing you need to know is that each of these little cells is a bit of code that we can run by pressing this play button. And then down here, you'll see the output. So the sort of the helpful thing that we can do here is if you put any of your variables at the very end of your cell, then Colab or Jupyter will automatically show you what's inside those variables. So this is kind of helpful. We defined 4 variables: myInteger, my floating point number, my string, and my Boolean. And then we just write them all separated by commas at the bottom here. And we get all of our variables out. So moving on, we'll look just at numbers. And obviously, we can do arithmetic. If you have done any other programming languages, there are no surprises here, right? If we have 2 numbers, A and B, we can do A plus B. We can do A minus B. We can do A times B with an asterisk. It's not an X, it's an asterisk. And we can do A divided by B with the forward slash. We can run that, and we get what we would expect. 25 plus 5 is 30. 25 minus 5 is 20, 25 times 5 is 125, and then 25 divided by 5 is 5, right? One thing to actually be aware of is that all of these are integers, and then at the very end, when we do division, it actually automatically converted it into a floating point number. That floating point number is a whole integer number, but formally it gives us that .0 to show us that, well, hey, you did division, you could have had a decimal part here, and so we're going to tell you that this is a float. Someone's asking, why are we not using the print function? The simple answer is because that's one extra thing we have to think about, and we don't have to in notebooks. We will start using it later, though. Yeah, I'm just trying to introduce things very slowly. So you can just write your variables at the end, and they'll get printed out. But great question. You could be using the print function here. Also, I already said it, but thank you all so much for helping one another out, dropping the links when people haven't seen them. That is incredible. You are the best. Okay, so we've done some arithmetic. You can play around with that. Someone asked, so Python converts the integers to floats. Yes, if you were doing division, this happens. Let's see. Okay, parentheses are also really important. They work just like parentheses in math. You'll do the parentheses part first, right? So we have 12 minus 6 divided by 2. Y'all, I should slow down a little bit. I'm gonna take a sip of water. So our calculation is 12 minus 6 divided by 2. But if we do the subtraction first, then we end up with 6 divided by 2, and that should give us 3. But if we do the division first, then we do 6 divided by 2, which is 3, and then we subtract 3 from 12, and so that should give us 9. And lo and behold, 3 and then 9. So this is just like Pandas, if you ever learned that in school. I don't know what they're doing in school these days. Okay, this is a great question. What are the keywords? And one thing that I'll throw out is that is super helpful about notebooks is that keywords get highlighted. So pretty much everything we're dealing with here is either a literal value, like 25, or is a variable name. So like A plus B or calculation, these are all just variable names, but great question. When we get to reserved keywords, they will be highlighted for us later. So excellent question. Another super helpful tool, which I think is in some languages but not all, is that you can edit a value in place. So if we said the day of the month is the 9th today, then we can increment that by 1 for tomorrow just by saying plus equals and then 1. And so we should get day of the month is 10. You could also do minus equals, and that will subtract 1 from the number. and then we have 8, right? You could also do times equals if you felt so inclined. We could multiply it by 2, and then you get 19. So that's something that we'll see used if we don't want to actually reference the variable and then add to it. That kind of just speeds it up, makes it a little bit more concise. Someone's asking about print statements again. Yeah, so we will use print statements later, but in Google Colab and in Jupyter Notebooks, you can just write your variable name at the very end, and it'll just show you what's in that variable, which is super helpful just for keeping things simple. Okay, so we've done numbers and we've done arithmetic. Incredible. Y'all are killing it. Do we have any other questions? I'll look at the chat really quickly. Looks like perhaps we got to most of them. Cool. Now we're going to look at strings. So this is something that if you are not familiar, a string is just the word we use for text. String is text, text is string, right? You can say that you're using a string by putting it in quote marks. This is something I mentioned is you can use double quotes. It's just a style thing. I prefer single quotes, but if you want to use double quotes, be my guest. And the reason that we have to put it in quotes is because otherwise we might be talking about a variable name, right? Like, for example, I could make a variable called will, and that could be equal to 4 or whatever. And if I didn't have these quotes, well, then it would think that I was talking about the variable name will. But I put it in quotes, and that makes it clear that I am talking about the actual text will, not the variable called will. So one fun thing we can do with strings is that we can concatenate them together. That's just a fancy word for smashing them on the ends of one another. So we can say hello plus whatever's in my name plus an exclamation point, and we store that in greeting here. Ooh, someone's asking about Python versus R. I would love to answer that question. Will you save it till the end? I think we'll have some time for like a Q&A, and that's a great question, but I could get super sidetracked on that. So save that one at the end. That's good. Let's see. How much to master Python for getting into machine learning? A great question, and I will say that if you stick through this week, you will see kind of how much Python you actually have to know before you can do cool things with machine learning. And the answer is like not that much. You're always learning. Someone mentioned this, like I am still not a master of Python, even though I love it and use it a lot. But yeah, you don't actually need that much before you can start doing interesting things with machine learning. Okay, back to strings. Strings are text. We can add strings together and we get a fancy little output. One notable thing that sometimes trips people up is that I put a space here because I wanted that space to appear right there. If you didn't put that space, it wouldn't magically insert a space for you, right? It would just say hello world. So if you're doing something like that, often you will put in an extra space at the end of one word just to make it format correctly when it all gets concatenated. Also, concatenate, another one of those terms, it just means smashing the things together. So this is something that we can do where we have string plus string. But usually if we are trying to format something, we'll use this really cool feature in Python called a format string. And the way that we do that, this is a format string right here. We start with just the letter F, and you can see it's highlighted because that's a keyword. That's not just the letter F. That means we're using a format string. Then you put your starting quote, and then you write whatever you want your string to be. But notably, you can then do opening and closing curly braces and put a variable name in the middle, and that will magically put that variable sort of in the middle of that string. So when we run this, we should see my favorite drink is a cortado. It's the best. That's a kind of espresso with a small amount of milk. One other thing to throw out here is that when you are doing quotes inside of quotes, you can do a little backslash before them to allow you to write the quote. Okay, let's see. Still trying to figure out how to upload the code. Yes, okay. This might be a good time to really quickly circle back around and show you the getting the code part. So what you're going to want to do is, if you are seeing anything like Colab, you can click Open a New Notebook. You should see a screen like this. Click on GitHub. And then you can actually just type wliffert. But the link that is going to be most helpful is to drop this link right here and then press search. And that should bring you up to this right here. And if you click on this, that's the document we're working on, and you're home free. You're fully caught up at that point. And that is that. Okay, so we have talked about strings a little bit. Another super helpful tool that you can use for strings is called the length method. And we'll talk a little bit more about like this format, but you just type the word len. You can see it gets highlighted, and then an opening parenthesis parens, and then a closing parens with your string in the middle. And this will tell you how many characters are inside your strings. There are 81 characters inside this string. If you'll ask later, I have 2/3 of the places you'll go memorized, and I can run with it. So, you know, if anybody gets me pepped up, I might start quoting the places I'll go at. The places you'll go at you. One more tool for strings before we keep going is that you can get individual characters from the string using square brackets. So, the places you'll go, that's our string up here. And if we do square bracket 5 and then close square bracket, we will actually get, not the 5th letter, but we will get the 6th letter. This is, if you've done this before in other languages, we start counting at 0. So we count 0, 1, 2, 3, 4, 5. And so that's the 6th number. So this will actually get us the 6th letter from our string, which in our case is 1, 2, 3, 4, 5, 6. And that's an A. Someone asked what the backslashes do, and I'll actually show you. So if we don't use a backslash, then it will actually think that this is the end of our string, right? Because our string started with a quote, and then it ends with a quote. And so if I run this, it'll give us an error. Oh no, it's an error because of that quote. So we have to give it a backslash just to say, this is like a fake quote. This is not a real quote. Or maybe it's a real quote, not a fake quote. I don't know. But it just tells Python, this doesn't end the string. Excellent question. Someone asked if this is what's called slicing. Kind of. We can talk more about slicing at the end. It's not something we use too much in this track, but it is really cool. It's a cool feature. So if we have time, we will definitely do some slicing. This is what I would call just indexing, but slicing is a form of indexing. Googling escape characters in Python is great. Oh, what a great question. Where do we check in for this workshop? So if you have made it this far, which I'm just utterly tickled to death that you have, then you definitely should sign up for this workshop. If you have not filled it out yet, or if you've not checked in, I will drop the link for you right now. Oh, someone else got to it first. Okay, well, I'm going to send it just so it'll go on all the platforms. But as ever, thank you for dropping links, everybody. It is greatly appreciated. Alrighty, so we've done strings. We have a couple strings that we might look at, or a couple string questions we might look at the end. Slicing. Someone remind me about slicing later if we have time. And now we'll move on to our last kind of variable that we'll look at, which is a Boolean. Boolean is, again, one of those fancy words that means something simple, and it's just true or false. If you ever took a true or false test, that is, you were giving Boolean answers. It's either true or it's false. There's no in between. So usually we will use a Boolean to say some kind of idea is true or false. So for example, is it sunny in Seattle? Technically today it actually is sunny, so this is a lie, but I thought that it wouldn't be sunny because I live in Seattle. And then here's another statement. I want coffee, and we're setting that to true. Someone asked if we're going to do looping today. Yes, we get to looping in just a second. So you're in the right place. So we have Booleans, which are nice. We can just say this is true, this is false. But what's really powerful is that we can combine Booleans and with logical operators. So our logical operators are things like and, or, the word not is also a logical operator, right? And maybe actually we'll look at these one by one. So I'll get rid of this. So if I'm saying sunny in Seattle and I want coffee, if I run that, that's false, right? Because even though I want coffee is true, I want coffee and sunny in Seattle are not both true. So that's what the and does, is both of them have to be true in order for the and to be true. Then maybe we'll look at the or statement. So sunny in Seattle or I want coffee. If we run this, it actually is true because only one of our things needs to be true in order for the or of them to be true. And then finally, we can throw in not. So I want coffee and not sunny in Seattle. This will also be true because sunny in Seattle is false, but not sunny in Seattle just flips around and becomes true. Boolean logic is something that is not that complicated, but the more you think about it, like the more complicated it seems. So you don't want to get too bogged down in this, but you know what and means, you know what or means, you know what not means, and all of these are kind of helpful things that we might deploy. Someone's asking about my variable names about snake case. Yeah, so there are a couple different ways of writing variables, right? There is Camel Case, and this is used in like Java a lot. I think in some cases it can also be, well, lots of languages that use this. Python, the recommendation usually is to do your variables in what's called snake case, which is no capitals and you just put underscores. I happen to think that snake case is just like a better form of naming things anyway, because you have spaces where there are spaces, So I like snake case, but that's not a law, right? You can write variables in Camel Case and Python will not complain at you. Fun fact, actually internal at Google, there's a style guide that says that you should do variables in snake case and functions in Camel Case. That's what Google does. So follow your heart, but yeah, we'll be using snake case for a lot of things here. Oh yeah, someone gave us the full list of all the cases. Good stuff. Yeah, also makes sense because Python is a snake and we're using snake case. Okay, so everybody pat yourselves on the back. We've gotten through our first little section here. And now we have a challenge for you, right? So if you're here, you should be able to just hit return in this little thing and embark on this challenge for a second. See if you can make it happen. So the challenge is to create a variable called my age that holds your age, and then create a variable called my name that contains your name, and then create a string that says my name is Will and my age is 25. Only Will and 25 should be replaced with your name and your variable. Okay, someone's asking, do we have to define what type of variable it is before we create it? And the answer is no. Python is not explicitly typed, and it just infers the type from the thing that you put in it, right? So yeah, this is actually, I'm going to give everybody a second to try this challenge, then I'll show you. But while we're waiting, I'm actually going to throw in something else here. There's a cool function called the type function, which allows you to find the type of a variable, right? So this variable foo, I'll put the string AAA in it, and then bar, I'll put the number 35. And so if I say type foo, and it tells me that that's a string. If I say type bar, it tells me that's an integer. If I change bar to 0.1, 35.1, now it tells me that's a float. So there is a super helpful way to know what's inside your variable. Let's see. This is missing a word in the URL, hence broken. Which URL is broken? Was it the one that I dropped for signing up? If it is, I deeply apologize. Cool. Okay, yeah, people are even dropping in some of their solutions. So I'll jump down to the challenge. Okay, so we want to make a variable called my age, and we want to put in our age. So for me, that's 25. We use that equal sign because that's the assignment operator in Python. And then we will say my name, and then we will say single quotes, and we'll say Will. And then if we want to create that string, I'll maybe even call it my string, and I'll do a format string. So I'll say F, and then single quotes, and then I'll say my name is, and then I'll use those curly braces to say my name. So now this will reference that variable. And then I'll say, and my age is, and then I'll say curly brace my age. So that now references the my age variable. And then I can just write my string. And look at that. My name is Will and my age is 25. I think a lot of people got the right idea here. They're dropping it in chat. Someone asked a great question that is, are all programming languages this similar to one another? This seems like a simplified JavaScript. Yeah, this is a great question. And I think that once you start learning programming languages, you will start picking up a lot of crossover. There's a lot of cross-contamination. One reason this is because Guido van Rossum, the person that created Python, he used other programming languages before, right? And that was his kind of starting point. This is kind of a tangent, but I know a tiny amount of Spanish, and then recently my boyfriend and I have tried to learn Italian together, and it's rocking my world how much similarity there is between Italian, and Spanish. There's like a lot of words that sound similar. And this is for good reason, right? So yes, a lot of programming languages look really similar. There's a lot of things we could get into. I don't want to get too sidetracked. But there are a lot of different ways of organizing your programming languages. And one of them is with the idea of languages being high level or low level, right? A low level language is one where you're really interacting with the bits and bytes on your specific computer. And a high level language is one where you are really abstractly thinking about sort of big ideas and not worrying too much about the tiny details. And so low-level languages are things like C or Rust, and these look a particular way and perform a particular way. And then there is also languages that are kind of in the middle, like I would say Java and C++ are kind of in the middle. And then you have languages that are really, really abstract, what we call high level. And languages like Python and JavaScript fall into here. Haskell is a whole thing, but yeah, Haskell would be considered a high-level language as well. And I really like high-level languages because they let you do a lot of things really fast. But sometimes they kind of do magic for you behind the scenes. So it's something to be aware of. But I would say that JavaScript and Python, because they're both high-level languages, they often will feel pretty similar. So I think that's a good comparison. Someone was asking what the F stands for. And yeah, that just makes it a format string. This is a great thing to play around with. What if I just delete that F? Well, now this is just literally a normal string. My name and my age don't get replaced with anything. And so it just prints out literally that string that I wrote. But if we put back that F, now it's a format string, and it formats in those variables. Great question. Okay, y'all are going to get me on like a JavaScript rant because people keep mentioning JavaScript. But I will say JavaScript is nuts, okay? JavaScript is like always changing, and like every 3 days there's a new framework, and they just can't sit still. And I know a lot of people love that, and it's dynamic and it's exciting. But I like learning something, and then the next year that same thing being true. And this is my case for Python supremacy over JavaScript, okay? We can all fight about this later. Cool. So we finished our challenge with our first little section, and we're making great time. So someone asked about data structures, and we are actually going to look at some data structures right now. Actually, one more question that we're going to answer. How do we concatenate int variable in string? So this is a great question. First of all, the thing that I'd recommend is just to use a format string like this. So in this case, my age is an integer, and the format string just knows what to do. It converts that integer into a string in a sensible way. If you wanted to do something like, a lot of times people try to do something like my age plus my name, and this will give us an error, because I don't know how to add integers and strings, right? And so if you want to do something like this, you can use the string converter, where you can convert that integer into a string, and then you're adding two strings, and that then works. That's kind of a silly phrase, but it works. So you can kind of convert that. But I would recommend using format strings in most cases. Cool. I love the sick burn on Java. Where's the Java crowd? Probably working their boring desk jobs. Yeah, I don't love Java. Okay, y'all really are getting me sidetracked. Here's my problem with Java is that if you asked me what my perfect programming language was, I would describe a couple things to you. I would say, oh, it should be like really portable and easy to run everywhere. And I actually want it to be explicitly typed. But I also want it to be higher level and have a lot of cool utilities. And then you would tell me, Will, you're describing Java. And I would be, yeah, but Java sucks, right? So Java is a tough one for me. Someone asked how many programming languages I know. That's kind of a tough question to answer. I've dabbled in maybe 20 programming languages. I will say definitely Python is the language I use the most. It's the language that I use at work at Google. I also use languages like Go and JavaScript, and I actually use a decent bit of SQL these days. I originally learned C++. Those are some of my more common ones. I actually really do like Haskell. I've never done anything serious in Haskell, but Haskell is pretty fun. But yeah, I've played around with a lot of things. Okay, we're moving on to lists and dictionaries. And this is where things get super interesting. Also, there's a question about Python jobs and salaries and stuff. That's an interesting question. Save that one to the end because I've already gotten too sidetracked already. Okay, we're going to talk about lists and dictionaries. Oh, one fun fact we didn't cover is that sometimes Colab will collapse things. And so just press that little arrow and it'll show all the cells underneath it. But it could be nice to kind of clean up and collapse our cells from previous sections. So far, we have been only dealing with single variables at a time, right? My age is just the age of one person, me. But oftentimes we have variables where we have multiples of the same kind of thing. And this is a great case to use what we call in Python a list. A list is very similar to arrays in a lot of other languages. It's just a little bit higher level and a little bit more flexible. But basically how we can create a list is using square brackets, putting in our values, separating our values by commas, and then at the very end of our list, putting a close bracket. So now we have a variable that doesn't store a single value, but it stores a list of values. You can even hover over it and you can see that. We add new things to a list by using what's called the append method. So we'll have the name of our list, then we'll do a dot, then we'll write out the word append, then we'll do that open parens, and we'll put whatever new thing we want in our list, and then we'll do a close parens. And so then we'll write cities to see what comes out at the end. As you can see, we have Nashville and Boston, and then we added Seattle. Fun fact, these are all the cities that I have lived for a substantial amount of time. So lists are cool. A couple weird things about lists. In a lot of languages, you can only put one kind of thing in a list. Not so in Python. If you want to put a number in there, if you just wanted to put 3, you're allowed to, which is like kind of powerful, kind of cursed, if you asked me. I don't think there are a lot of good reasons to put different kinds of variables in a list. Normally, that list, you want it to just be one kind of thing. But you can if you wanted to. I'm going to ask for the working link for the event in Organize. If someone could drop that, that would be incredible because I already closed out of it. OK, so we have created a list. We know how to append things. And we can also, similar to lists, or similar to strings, we can use square brackets to index into our list. We can hit return. And so, OK, well, that was because I added 3 in there. Let me run this again and get rid of the 3. And so we have our 0th city is Nashville, and then our city at the second index, which would be number 3, is Seattle. Someone mentioned this as well, that lists are mutable. And this is another funky word that's actually a really helpful term to know, which just means you are allowed to change it, right? Because we were able to append something, and that changed our list. We even can, we can index here. We can even reassign indexes, right? So let's say I'm leaving Seattle and I want to move to New York City. And so we can actually change what occurs in the number 2 slot, or the number 2 index. So we didn't add New York City, we just replaced Seattle with it. Whatever was in the third, or the number 2 index, we just replaced that with New York City. This does get a little bit wonky, but yeah, tuples, we're not going to cover them. Tuples are great. They're kind of like lists, but you can't change them. And there are lots of nerdy reasons why we like to have them around. But we'll get to that we maybe get to that at the end when we're talking about more nerd stuff. Right now, we're sticking to the basics. So the next structure we want to look at. So a list is what's called a data structure. Another kind of data structure is a dictionary. So sometimes our values don't really fit into a list. Sometimes we'll have this pattern of key value pairs. So for example, I might want to look at the populations of cities. Well, I could have just a list of numbers that are the populations, but they don't really mean anything to me if I don't know what city they go with, right? These are really pairs of values. And this is a really, really great example of when a dictionary is useful. So we can create a dictionary kind of like a list where we say, this is our variable name. We use the assignment operator. Then we use a curly brace. And then instead of individual values, we'll have a value or key, and then a colon, and then our value. So on this line, Nashville is the key, and 692,587 is the value. And then on this line, Boston is the key, and 684,379 is the value. And we can then print out that, and we can see, okay, Boston maps to that number, Nashville maps to this number. this is a super helpful construct that we'll kind of look at in a little bit more depth on what we can do with it. Yeah, so someone asked if we can review dictionary again. So a list is just a bunch of values in a list, right? There's no context really, but sometimes we have sort of a key and a value, right? Something we want to sort of look up. And so what a dictionary does is allow you to store a bunch of pairs of values, and you can look up one value based on another one. So I think it's really helpful to look at an example here where what if I want to store all of the populations of cities? And what this allows me to do is to say the city is Nashville, and the value that I have stored for the population is this number. And so we get the full city population, but what's super helpful is being able to look up a single thing. So we could have a big map or a big dictionary of city populations, and we can give it the city, and it'll give us back the population. Someone's asking if this is what hash maps are. Yes, a Python dictionary is implemented in a hash map. Fun fact, I rarely read the sort of source code of programming language built-ins, but I have read the source code for the Python dictionary, and it is a good read. I would recommend it. It's kind of cool, and it's not that hard to understand. Maybe by looking at some examples, we can then maybe understand dictionaries a little bit better. Someone asked, do I recommend learning Python over JavaScript? This is another one. Save for the end. I would love to riff on that. I would love to talk about Python versus JavaScript, but let's soldier on for now. But great question. So dictionaries, we can store sort of a key and then a value, and then we can use that key to retrieve the value that we stored. If we want to add a new pair of values, we can just say, we can index it like this. So we'll say Seattle of city populations, and then use that assignment operator, and then we'll put in our new value. So now if we run it, we can see, oh, Seattle is in there, and it has its own population stored in the dictionary. Super neat. One good thing to realize is that a dictionary is kind of like a list, only a list always indexes on numbers. It's always 0, 1, 2, 3, 4, 5, whereas a dictionary can index on something else, right? So this is also what we would call indexing, but the index is not a number, it is the name of the state that we're storing for. Another super helpful tool is that if you just want to see just the keys of a dictionary, you can just say .keys, and this will actually give you a list of all of your keys. So it basically goes through and says, there's a key, there's a key, there's a key, and gives you all of those. That can be super helpful. Someone asked, what do we do if we want to update the value of a key? That is a great question. We can actually do the same thing as assigning in the first place. So here, Seattle, it was 724,305. But we could, oh, what did I do? Okay. We could say that's actually equal to 7, and then we could, see what's in city populations again, and it's now been updated to 7. Great question. Updating works just like assigning kind of in the first place. So someone said, can you tell us about the specific use cases for both lists and dicts? Yes. So usually if you know all of the context about your variable, then you will use a list. So like a good example is if you are going out and like doing a science experiment and measuring something, like say you're measuring the height of flowers, that's like a great example where you don't really care which flower it is. You just went and you measured a bunch of them and you store that in a list, right? Then you can like take the average of all of those heights or whatever. Maybe not a great example. Or like a shopping list is maybe another good one where you say, I want to get bananas, I want to get oranges, I want to get cereal or whatever. That's a list. It's when you have a relationship between two kinds of values that you want to turn to a dictionary. So, I mean, like names and ages is a good example. If I want to keep a list of everybody's name and age, well, I don't actually want to keep a list because a list can only store kind of one thing in there, kind of. But I want to say, hey, what's your name? And I can go look up your age based on that. Again, we're going to look at some more examples, and I think that examples might be more helpful than me just saying, well, this is something you could do. So hopefully over the next little bit, kind of, we'll get some more familiarity with lists and dictionaries, but great questions. Oh, someone's asking about running time complexity, which is great. I don't want to get into that right now, but we can talk about running time complexities in a second. Also, yeah, talk amongst yourselves. You can chat about running time complexity. Folks probably know. So now we have another challenge. Here we want to create a dictionary that maps the names of you and a couple family members or friends to their ages. Then give yourself a birthday by adding 1 to your age and display the resulting dictionary. So I will, I'll line code here. I will say, let's say ages. And I'll do those opening and closing curly braces. And so then I know I can write name and then colon age. That's just my template there. So I will write my name. I'll say Will. My age is 25. Then I can say John is my brother, and he is currently 27, 26. Oh, I'm a bad brother, y'all. Is he 26 or 27? I don't know. And then my boyfriend, Richard, and he is 23. I can print out ages. We see those. But now I want to give myself a birthday. Let's say Will plus equals 1. This is a super helpful pattern where you just say, I want to increment whatever is stored there by 1. And then I'll print out ages. And now Will is 26. Incredible. That is the completion of our next challenge. All right, let's see. We got some more questions. Can you give some resources for data structures and algorithms and preparing for interviews in Python at the end of the session? I haven't found really much helpful. Y'all, I love talking about interviewing. So actually, give me talking about interviewing and I will never stop. So yes, I would love to talk about data structures and algorithms for interviewing. I actually do a lot of interviews at Google where I'm the one giving the interview and coming up with the question. So it's something that I'm super interested in. Ask me about it later, but yes, absolutely. Another great example of a dictionary. Yes. If you have like account data to log in, so you have username and a password, right? So if someone gives you the username, then you can look up, do they have the right password? That's a great example. Someone asked, are we going to submit these challenges? These challenges here, no, don't worry about it. This is just to kind of help you play around and learn. We will actually have a sort of competition within this track later that I will tell you about at the next session. So stay tuned for that. Someone asked if I know any other languages. I mentioned, yeah, Python, Go, SQL, JavaScript, C++ are like my big ones, but I've dabbled in a lot of things. Another great question is, are dictionaries ordered? And the answer is no. And this is a little bit confusing for people at first. But so, for example, I wrote Will and then John and then Richard. But when I printed it out, it said John and then Richard and Will. And that's because it does not keep them sort of in linear order. The only thing that it does is make sure that Will is always next to 25, and John is always next to 27, and Richard is always next to 23. So the only relationship that exists is between the key and the value, not between pairs in our dictionary. This is a great question. And some people are like, wait, that seems broken. Why do we do that? The answer is there are reasons. It's complicated. But the big thing is that we usually don't care about order. If you care about order, then that is probably a pretty good indicator that you want to use a list and not a dictionary. Let's see. Yeah, someone said, not recommended from a security standpoint. Don't store your passwords in plain text in a Python dictionary. That's a bad idea. But it's a good example of the kind of thing you could use it for. Google is saying it's ordered as of 3.7. That's an interesting assertion. If it is, that's big news. I'm actually going to take a break and Google if dictionaries are ordered. I'm curious what that would look like. Python dictionaries ordered. Dicts are now ordered. Get used to it. Wow, this is massive. I love this. Okay, this is something I'm actually going to read on more, and we might talk about it at the next session because this is cool. Right on. Someone asked if we can perform functions on values such as addition and subtraction. Yes, you can do. You could also demote me an age by -1 here. Oh wait, that's not what I meant. Minus equals. So now I'm 24 instead of 25. Great question. Yeah, so dictionaries changed in Python 3.6. That's super compelling, and we will talk about it next time because I'm very into that. Let's see. So I'm asking what my typing speed is. I have no clue, y'all. I've heard that I'm an angry typer, and so if you hear me typing and it's like bothersome to you, I'm sorry. I'm not going to change. I'm going to keep typing loudly. All right, charging ahead. Part 3, we're going to look at ifs and loops. We are really building our Python toolbox here. So first we're going to look at if statements. And to talk about if statements, it's really important that we learned about Booleans first. Now, it's been a minute since we used Booleans, but remember, Booleans are just true or false, right? So here's a Boolean: pineapple belongs on pizza. That is, of course, the value is true, because that is a true statement. Pineapple on pizza is delicious. The way that an if statement works is we can basically check some condition, and then we can do something only if that condition is true. Now, one thing that gets super interesting in Python is indentation. In a lot of languages, you might be used to something like this, where we have a curly brace opening a code block and then another curly brace closing the code block. This is how code blocks work in a lot of languages. Python strives to look very clean and to enforce some good formatting. And so in Python, we don't use curly braces. We use a colon, and then everything after that colon has to be indented. So here I am using 4 spaces, and it'll automatically do that for me. Oh, 2 spaces now. But this basically just means that everything that's indented after here is part of this block. So if I run this, because pineapple belongs on pizza is true, this should run for us. And look, it prints out for us. If we, on the other hand, change this value to false, it doesn't print out anything, right? Let's change it back to true. And just to demonstrate this whole indentation thing, we could print out something else. And boom, something else prints out as well. Now, if we actually come down here and we're not indented, and we can say something outside code block. So when it's true, that prints out. But if we change it to false, these 2 things that are indented won't print out, and this last one will print out. Because it's outside the code block, it's not governed by that if statement. I love to see some love for pineapple on pizza in the chat. This is good. This is good shit. Incredible. So that's our first look at an if statement. Let's charge ahead. So another thing that we can do with if statements is tack on what's called an else statement. And basically, an else statement executes only if the original if statement doesn't run. So in this case, I have the Boolean mashed potatoes are good, which of course is false. I do not like mashed potatoes. And so in our if statement, we'll say, okay, if this is true, we'll run this line of code. I like mashed potatoes. Otherwise, if this doesn't run, then we'll print out this print statement. And because it's false, this line doesn't run, and this last line does run. Mashed potatoes are literally baby food. If we change this to true, then we would see that reverse, but it grosses me out. I'm going to change it back to false because I don't like mashed potatoes. No shade. If you're like really into mashed potatoes, like live your life. But you know, here in this stream, we're a no mashed potatoes family. Okay, another big idea we want to get out as we're diving into if statements is the idea of comparisons, right? Sometimes you don't just have a Boolean by itself. Sometimes you need to compare 2 different values to see if you want to run a block of code. So for example, in the US, you have to be 16 years old to get a driver's license. So if we said my age is 25, then I would compare that to 16 and say only if my age is greater than 16, actually we would say greater than or equal to 16, then we would print out you can get a driver's license in the US. We can also use a comparison called the equality operator. So earlier we used a single equals sign, and that was assignment. That was putting a value into a variable. But if we want to actually say, are these 2 things equal to one another, then we use the double equals sign. This shows up in a lot of programming languages. That's pretty common. So if you are 22, we print out, I don't know about you, but I'm feeling 22. This is actually, I'm going to break this into another code block because I'm throwing a lot at you really quickly. So we can run this. So you can see because I'm 25, this printed out because I'm greater than or equal to 16 years old. But I'm not equal to 22. My age isn't equal to 22, so we didn't print that out. If we then change to 22, then we get both of those because 22 is greater than 16. It also is equal to 22. And then for completeness, if we change this to 12, then neither of them would print out because you are neither greater than or equal to 16, nor are you equal to 22. I am a Taylor Swift fan. Yeah, the total T-swizzle head. Swiftie, is that what they're called? Am I a Swiftie? I don't know. I'll change that back to 25. So it'll be true. Another set of tools we can use is earlier we looked at logical operators like and, or, and not. And we can use those in our comparisons as well. And they can be really, really helpful. So for example, I live in the States. When I'm talking about weather, I use Fahrenheit. When I'm talking about boiling water, I use Celsius because duh. But if I'm talking about weather, I'll use Fahrenheit. And so let's say it's 82 degrees Fahrenheit outside and the weather is sunny. So this is a kind of complicated chunk of code, but I want you to really look at it and see if you can understand what's going on here. So we say if the temperature is greater than 70 and the weather is sunny, then we're going to print out, let's go to the beach. Elif, this is a new thing we're throwing in, but hopefully it's pretty sensible. It's just another if statement that we only run if this first one didn't run. If the temperature is less than 32 degrees and the weather is snowy, then we can print out, let's go skiing. And if neither of those things happen, then we just print out, let's stay inside. So if we hit run, if it's 82 degrees and sunny, it says, let's go to the beach. If, on the other hand, if the temperature dropped to 40, and now it says, let's stay inside. It's not great weather for skiing or for going to the beach. But if it drops down to 20 degrees and the weather changed to snowy, we could run that and it would say, let's go skiing. Let's see. You can't delete comments on Twitch. Yeah, the internet is forever. Y'all should know this. Comments don't go away. Someone is liking this session, and that warms my heart. I'm really, really glad you're enjoying it. Someone asked the difference between if and elif. Yeah, so elif just is a squashing together of else if. So else doesn't have a condition. This will print off as long as neither of these two things happen, else will always happen. But elif is basically just chaining another if statement. So it's if this doesn't happen, if this is not true, but this is true, it allows you to give kind of another condition that could be true. Sometimes words make things more complicated, but maybe a way of looking at it is that it's just if you have a different condition that could be met, you can just place elif after your first if statement. Yeah, I think it's a good explanation. I think usually we like our Python to look kind of like natural language you could just read. So, if the temperature is greater than 70 degrees and the weather is sunny, then we do that. Else, otherwise, if the temperature is less than 32 degrees and the weather is snowy, let's go skiing. Otherwise, let's print, let's stay inside. So talking it out can be helpful. Someone asked, can I use two ifs as well? This is a good question. And the answer is technically yes. Yeah. Let's actually look at an example of this. So let's say we have a letter, and our letter is A, and a number, and our number is B. Or sorry, our number is 1. And let's say we have if letter equals A and number is greater than 0. We'll print booyah. Then we'll say elif letter equals, not the assignment operator, the equals B and number, actually, no, let's say letter is A and number is greater than -1. Then we'll print hello. This is kind of just a random example that I'm making up. Yeah. Sometimes words do make things more complicated. This is really true. And then we'll say else print, let's say ... right? So here, and actually I'm going to change this. I know this is making it more complicated. Let's say 3, and let's say greater than 2. And then this second one is greater than 0. So if our letter is A and our number is greater than 2, then we'll print out booyah. If our letter is A and our number is greater than 0, we'll print out hello, and then otherwise we'll print out ... So if we print this, it says booyah, right? But what will happen if we change this not to elif, but just to another if? Well, now we're not saying only if this fails. We're just evaluating these separately, right? If we put if, we just separate those statements out. And so now, well, our condition actually meets for both of them, and so both of them will print out. That's maybe an illustration of why you would pick an else if versus just another if statement. Okay, now we're getting to loops. We're flying, y'all. This is going great. Excellent questions, by the way. Y'all are killing it. Y'all are really getting your bag. We can use loops to do something multiple times. Loops are really helpful when we're working with lists. Loops are something that are a little bit different in Python than from other languages. In Python, we have what's called a for in loop, where we basically just say, we're going to do this chunk of code for every item in a list. So say we have a list of students, and the names are Marco, Elizabeth, and Eric. We can say for, you can see it's a keyword or a special keyword because it's highlighted. So we say for student in students, and then we have a colon. So the way to read this is that our list is students, and we're going to go through each one of them, and we're going to take a turn where we say the student is Marco. And we're going to take another turn where we say the student is Elizabeth. And we'll take a third turn where we say the student is Eric. And so this will get executed each one of those times. And the first time it'll say student is Marco. And the second time it'll say student is Elizabeth. And the third time it'll say student is Eric. So if we run this, we should get this welcome to class 3 times with everybody's name. And you can see, in fact, that's what we get. We say welcome to class Marco, welcome to class Elizabeth, and then welcome to class Eric. I'm really glad to hear that folks that thought maybe about skipping it showed up and that it's actually helpful. I think it's fun to actually get into some of the details here. I know that there are a lot of things that it's like, I may have learned that at one point, and now I'm going back over it. It's like, oh yeah, I mean, like I think dictionaries being ordered is a great example of something that I totally learned today, even though I have spent a lot of time with Python. So hopefully things are actually being helpful. Incredible. So that's our basic list. Do we have questions about, or sorry, that's our basic loop. Do we have questions about loops? In Python, I'll reiterate this, you usually have a loop that touches a list. Lists and loops usually go together. So this is just a single line of code in our loop, but we can do more complicated things, right? So come down to here. This kind of looks like our weather example from earlier. So we have a list of weather forecasts. So let's say today it's sunny, tomorrow it's supposed to be rainy, and the day after that it's supposed to be sunny. We could actually keep a count of all of our weather forecasts. So we could say how many days are supposed to be sunny, how many days are supposed to be rainy, and how many days are supposed to be snowy. So we can loop through our forecasts, which means the first time we loop through, forecast will be sunny. The second time, forecast will be rainy. And the third time, forecast will take a turn being sunny again. And then we'll run this chunk of code that is another one of those else-if statements, those if-else statements, where we say if the forecast is sunny, we'll increment the sunny day count by 1. If the forecast is otherwise, if the forecast is rainy, we'll increment the rainy day count by 1. And then if the forecast is snowy, we will then increment the snowy day count by 1. Again, I'm going to say we're getting 2 chunks of code that are no longer like one line super simple. So take a second to kind of read through this and see if you can understand what's going on. Often it helps me to try to read it as if it is natural language, right? So I'll say for every forecast in our list of weather forecasts, if the forecast is sunny, add 1 to sunny day count. Otherwise, if the forecast is rainy, add 1 to the rainy day count. Otherwise, if the forecast is snowy, add 1 to the snowy day count. Someone asked if we can give a second for this chunk. Absolutely, yeah. In fact, because this is like a little bit of some meteor code, why don't we take another break and I'll play some Kalimba. And we can, if you need to run to the bathroom, great time. If you want to look at this code and just try to digest it, then please take that time as well. And I'll do another song in the Kalimba that I'm trying to learn. All right. Can anybody name that tune? I don't know. It's pretty rough. I just learned that for a second. Just learned that a second ago. Let's see. Yes, that is the kalimba. Okay, someone asked, when does the loop stop? This is a great question. And the answer is that the loop stops when the list runs out. So every item in this list means that we're going to run this loop once. So for sunny, we run this loop once. For rainy, we run this loop again. And then for sunny, we run it a third time. So if you are looping over a list and you want to say, how many times does this list, or how many times does this loop run? Just look at the length of your list. Another fun way we could actually do this is say len weather forecasts. We print that out. You could say 3. It'll run 3 times. Let's see. Yes. Okay. Yeah. Somebody got it. That was All Star by Smash Mouth. Oh, someone mentioned the Windows XP startup tune. I love that video where they do Smash Mouth with Windows startup tunes. I can't play that on Kalimba though. I gotta get with that. Let's see. I like the song Demons by Imagine Dragons, but that was not it. Good guess though. I feel like a lot of Imagine Dragons songs have like little like glockenspiely sounds that kind of sound like Kalimba. Let's see. Someone said, "What if I want to run it backwards?" This is a good question. I will say this is another one that I will request that you hold for the end because there are a lot of interesting ways we could do that, and it's kind of a cool topic to talk about. So let's see if we can get to the end and then hit that one up. Okay, I'm going to take a drink of water and then break will be over. Incredible. So this is our loop. And at the very end, we can print out our counts, and we see there have been 2 sunny days, 1 rainy days, and 0 snowy days. If we wanted to add in a snowy day, we could just say snowy. We see now it ran 4 times because there are 4 things in our list. And then we're going to have 2 sunny days, 1 rainy days, and 1 snowy days. Let's see. One said, why is sunny stated twice in the weather forecast? This is a good question, and the answer is this is kind of how I came up with this list, is saying this is tomorrow, this is the next day, this is the day after that, and this is 3 days from now, right? So like if we wanted to, another fun fact with lists, you can break them up onto separate lines if you want. So today for me is Sunday, so we could say Sunday's forecast. Then we could say Monday's forecast. Then we could say Tuesday's forecast. And then we could say Wednesday's forecast. This is kind of how I was thinking about this list. Which a good point to reiterate is that lists are ordered and the order really matters. And so from saying today and then the next day and the day after that, then a list is a really great data structure to use. Let's see. Thank you for dropping in that link again. Isn't it too much work to manually add in items and then make the loop run? Yes. Yeah. If I was actually trying to build a weather forecast calculator app, I would not keep a static list of it. No, good, excellent point. Okay. So this is a loop, a little bit chunkier piece of code here. Another really cool thing we can do is we can loop through dictionaries. So here's a dictionary kind of similar to the one we had earlier, where I say ages. So my age is 25, Richard's age is 23, Benjamin Franklin's age, if he was alive today, would be 316. Now, what if we said everybody gets a birthday? And so we're going to iterate through, in a for loop, for key in ages. We're going to iterate through every single name and then give everyone +1 to their age. Now, this is a super interesting thing to know, is that when you do a for loop over a dictionary, you don't get the values, you just get the keys. So this really says the first time you run this loop, key will be Will, the second time key will be Richard, and the third time key will be Benjamin Franklin. So then we actually have to go and use that key, and we can say ages with that key plus equals 1. And then we can print ages. Incredible. This is a kind of a finer point to throw in. Generally speaking, if you are iterating through something, you don't want to add or remove items to that iterable. So we would not want to, like for example, in this scenario, if we said Actually, this will be a good example. If we said forecast append sunny, don't do this. I'm not recommending you do this. But this would be, every time we look at a day, we add a new sunny day to the end. And this is a bad idea. And it says, oh, wait, weather forecasts, the actual list. That was also a bad idea just because it was, the wrong variable. And we can see we're actually getting stuck. And this is actually an infinite loop. And I now have to come and interrupt this execution because that was going to run forever, right? So usually you don't want to add or remove things from a list when you're looping over it. Incredible. Go. So that's loops. Now we can move on to our challenge for loops. So the challenge here is to create a list of integers from 1 through 6, then to loop through that list and check to see if each number is greater than 3. If it is, print number is greater than 3, but replace number with the current loop, or with the current number. Someone asked, how is it an infinite loop? And I can touch back on that. Yeah, actually, maybe do the challenge, and then we'll talk about why that was an infinite loop. Or maybe I'll actually create a simpler version of this. So let's say, let's still use the weather loop. We'll start with this, and we'll just say for weather in weather forecasts, and we'll just print weather. So when we do this, we go through 4 things, and we see all of them come out, right? But if we, in the middle of this, said weather forecasts, and we said append sunny, what this means is every time we look at one item, every time we cross something off our to-do list, we add another item to the to-do list, right? So if we run this, same thing will happen, and we should see, oh no, it just keeps printing out sunny, right? And so we actually have to interrupt it. So every time we take something off of our list, we're adding something back, and that makes our list just grow infinitely. Yeah, good question. Cool. Flexing your extra hour of sleep. Y'all, sleep is so important. I'm like a sleepaholic. Sleep is so good. I got 7 hours yesterday, but I'm usually trying to run on a minimum of 8. Not gonna lie. Okay, back to our challenge. Hopefully folks have had a second to actually work with that. Okay, so we want to create a list. Well, I know how to create a list. Maybe we'll call it my numbers. And we then do the equal sign, and then we do some square brackets. And now I put my numbers in there. And so I'll put 1, 2, 3, 4, 5, 6. And then I will loop through them. So I'll say for number in my numbers. Then I will do an if statement, and I will say if number is greater than 3, and then I will print out, I'll do a format string, and I'll say number is greater than 3. Boom. 4 is greater than 3, 5 is greater than 3, 6 is greater than 3. Easy. Incredible. One thing I'll throw out here is that if we're doing a something where we're trying to count a range of numbers, there's a super helpful utility in Python called the range function. So we can say, instead of writing out 1 through 6, we can just say range, and we can start at 1, and we can stop at 7. We stop 1 later than the thing we want to stop at, because as soon as we get to 7, we don't actually produce 7. So 1 through 7 will actually give us the numbers 1, 2, 3, 4, 5, and 6. Oh my gosh. Hey, Hannah. Welcome to the party. It's good to see you. So here we get the same result. The one trick about the range function is that you are going to have to make your end 1 further than you think it should be. So the beginning is inclusive, but the ending is exclusive, is kind of the formal way we say it. Right on. That's the range function. Now we get to move on to actual functions, which is super fun. This is going to be a really short section. We're just going to look at one example because the answer, or the upshot here is that every function is really different, and every time we look at a new function, it's going to have its own things going on. So I just want you to be comfortable with the basic idea. So here are functions. Functions basically let us package up a little block of code and reuse it multiple times. So here is a simple function called myAdding function. I'm going to walk through the anatomy of this function. Okay, actually, I'm going to back up. Someone asked, so this automatically makes a list. And the answer is kind of. Technically, it is not a list. Technically, it's what's called an iterable. Actually, this is probably getting more sidetracked than we need to. But if I come down here and I say type of my numbers, if we use range, it'll actually say it's of type range. And there are some funky, quirky reasons for this. But if we wanted it to truly be a list, because it does act like a list in most of these cases, if we truly wanted it to be a list, we could use the list constructor and just force it into a list. And so now we see the type is list. But this is a good way of putting it, is that it is something we can iterate over, even if it isn't technically a list. There are a lot of things that are list-like. That's a great thing to touch on. Okay, back to functions, the anatomy of a function. So let's walk through this sort of piece by piece. This first part, def, this is just that keyword that says we're writing a function. This signals to Python, hey, I want to make a function, pay attention. Because I like to think that Python is just like not paying attention most of the time. But then we say, hey, I'm making a function. And then Python perks up. And they're like, hell yeah, I love functions. The next thing that we have here is myAdding function. And this is the name of our function. This is what we're going to refer back to later if we want to actually use this function. The next chunk we have here is opening and closing parens, and then two what we call arguments in the middle that are comma separated. And the upshot here is that these are just the inputs to our function. These are kind of the data that we want our function to run on. So in this case, we have a variable called foo and a variable called bar. And those are the two pieces of data that our function gets access to. We have this colon. This is similar to colons elsewhere. It just means that everything after this that's indented is part of our code block. And then finally, our last two lines here. This line just actually has some logic to it where we're adding our two arguments together and storing it in a variable called mySum. And then this last line is our return statement that basically says this is what our function gives back to us when we call it, right? So we're passing in foo and bar. Our function is adding them together, and then we're returning that value. Now, this is not a very complicated function. I would never actually write this function because I would just add two things together, normally, right? I don't need a function to do that. But it's kind of nice to look at this when it's really simple, and functions will get a lot more complicated sort of in the future. So if we add myAdding function, we can do 2 and 6, and we get 8. So someone asked, what is the data type of the arguments? And this is a great question. And this is, I actually think, this is like the one bad mouth thing I'll say about Python. Python, because it lacks explicit typing, things can get kind of confusing, right? So like normally we'd think of, I want to write a function and I want it to always take in like numbers or integers or something. But because of how this function is written, we could, instead of passing in 2 and 6, we could say hello, and then we could say goodbye, and it would add those two things together for us, right? The plus sign means something different, but it still runs. And sometimes this can be helpful and it can be cool. A lot of times it can just be confusing. Let's see, someone said, sorry for sidetracking again. Why do we generally use Fubar and related words as variables in computer science world? That's actually a great question. I don't know where foo and bar came from originally. I think the general idea is just you want two words that don't mean anything, but that can't be mistaken for like other symbols, right? So like, for example, like X is kind of a bad variable name because someone might actually think that X is like multiplication, even if it's not. So I know it's just, we use these as example words. They're kind of classic computer science example words. But I'm going to take a note and I'm going to say, look up the etymology of Fubar. And I will come back to you in the next session with some answers because that's a good question. Okay, someone says, what about command line arguments? Can we get them there? The answer is yes. You have to take some extra steps. If we have time at the end, that's something we can talk about. But you have to go through a little bit of a process to get there. Cool. So we wrote a function. Now we have a function challenge. So the goal here is to write a function that accepts a number as an argument and then returns that number times 2. Really simple, really similar to what we did. Let's say def. We want to tell Python we're writing a function. And then we'll say times 2. That's a good name. And then we will accept a number. Why don't we just call it number? Then we'll do a colon. When we hit return, we've indented in. And that means that this is a code block that's all going to run as part of this function. And in our previous one, we said we kind of did the calculation and then returned it. But you actually don't have to do those as separate steps. We could just say return number times 2. And then we can run times 2. And we can pass it the number, pass the number 1. Great, we get the number 2. Pass the number 5. Great, we get the number 10. Again, this is really basic, and this is not something that you would actually need a function for. But it's good to get in the practice of seeing what this looks like. So power to you for running through it with me. Let's see. Def twice of num plus num return num. Yeah, that also works. There are lots of different ways you can kind of express the same idea here. All right, I think it might be time for another short break because now we're going to jump into our last big section. And I'll warn you, it is kind of where it all comes together. Things kind of get pretty complicated pretty quickly, and they also get powerful. So it's really fun, but we do end up bringing in a lot of stuff pretty quickly. So if you need a drink, if you need to run to the bathroom, then now would be a great time to do it. Y'all, I need to get a different bottle. Every time I drink out of this bottle, I just like pour water on myself. I don't know if y'all can see it, but I just like literally, not good, y'all, not good. Ooh, okay, this is something I want to try for breaks. I wonder if I can actually have y'all look at the fish. Wonder if I can. You probably can't see any fish, can you? Would need a longer lens to actually make the fish look interesting. Oh, thank you. My fish actually don't have names, but I have a snail in there, and his name is Harold. Maybe I should just get a separate fish cam. Maybe that would be good. Okay. The insert for the Nalgene. That's a good idea. Yeah, my brother has one of those. It seems to help him too. I also could just become like less clumsy, but that will never happen. Mark my words. I will be clumsy till the day I die. Someone asked, are they goldfish? They are actually neon blue rasboras. Okay, how is? I promise I will find some way to actually show you the fish close up at one of our streams this week. I won't tell you which one, so you got to tune into all of them. But I will see if I can maybe string another camera over there. Oh, thank you for complimenting Harold's name. It means a lot to him. I did find Nemo, not actual Nemo, but my own personal Nemo. I don't have cats. I used to live with 2 cats, and the problem is I have a lot of plants, and the cats that I used to live with, they were always knocking over my plants and digging into them, which, I mean, they were kittens. They were my roommate's cats, and then we stopped living together. But I don't have cats. I'm thinking about getting a dog. I live in a townhouse in Seattle, and it is like just enough space where it's like, yeah, I would feel good about having a dog here, Yes, tune into all of them. That's what I like to hear. Ooh, can we name your fish? Yes, actually, I am totally down. I have 5 fish, and I'm totally down to let someone here name at least one of them. Maybe we'll let you name most of them. Stay tuned till the end, and I will give you the parameters for how I will let one of y'all name at least one of my fish. Doggos are awesome. Someone asked, is there any challenge related to this track on the challenges page? That's a good question. Let me look up the challenges page and run through it. Challenges. I'll say beforehand, there's not like this is like intended to be the challenge for this. I'm sure there probably is some overlap. We will actually create a little website later, and it won't have that many colors. Okay, I mean, so all of these are attending a live session. All of these count for that challenge, so that's good. You could create a demo video. A lot of those kind of count. I'm trying to see, like, there's got to be, like, yeah, there aren't any that are, like, super spot on. But, you know, there are always new ones every day, so check back in. Someone's giving me a name like Elon Musk and Grimes kid, XX Worm Lover XX. Can we name one of the fishes not a fish? Oh, these are actually some great names. Okay, I have to think about, like, it's going to be something like everybody has to, if you attend all of the sessions, then at the end, whoever attends, I'll like raffle off naming one of my fishes. We're also going to have a competition where whoever, we're going to predict housing prices. Whoever predicts the housing prices the most accurately, I think whoever wins that also gets to name a fish. So that'll be one thing. There also might be, actually, I would love if we memed things from this meta track. So here's right now what I'm saying. If you attend all the sessions, I'll randomly pick someone who attends all the sessions to raffle off one of the names. If you win the competition, like our little competition, there's no prize, but now the prize is you get to name one of my fish. And then if you make the best meme based on this track, and post it on the Discord, then you will also get to name a fish. Okay, those are my three fish prizes. TNF, totally not a fish. Damn, these are good names, y'all. These are solid. I could name one Python. I do love Python. That would make sense. My favorite fish's name was Doug, as in Quail Man. Accepted. Yes, okay, I'm glad y'all are down for the challenge. Random question. Do you connect with participants on LinkedIn? I'm a freshman in the US at a small school and trying to connect with recruiters from FANG companies. Yeah, absolutely. If you want to hit me up on LinkedIn, that's a great place to do it. I was going to wait until the end to drop this, but we're having a nice little break, so I'll drop it now. I have a Google poll or Google survey that is, I'm going to try to look at this every day. If you have questions about this session or questions about this session, any kind of feedback, any specific questions for me, I will try to look at that every day this week. The other thing you can do is I am on LinkedIn, and that is actually one of the places that I'm like, yeah, if you want to ask, like, I'm not the best at checking LinkedIn, but it is like a place that I do get on occasionally and will, if you drop me a line, I will attempt to respond and kind of answer whatever questions you have. Someone asked, can I tell my journey to Google? Yeah, actually, I love talking about that shit. Maybe later. I'm trying to think of what the best time would be. Maybe at a future session if we have some more extra time. I don't know. I'm feeling I have to have like another separate session just for like hanging out and chatting, because there are lots of cool things to chat about. Actually, come to my coffee mini event on Tuesday. I'll drop the link for that later as well. That one's going to be a blast, and we'll just chat a lot there. Just drop my LinkedIn so you have that. Okay, cool. Nice little break. Now let's get back into it with our kind of final big section. I also think I have 2 hours and then like something else happens and I get kicked off because I would be like, oh, we could just go for 3 hours and kind of hang out. Someone asked what that form is for. And that is just if you have any feedback or questions, I'm going to look at that with the responses from that form every night. And I will sort of decide, or I'll look at them. And if questions pop up a lot, I will try to respond to them. You don't have to fill out that form. But actually, fill out the form if you want to be entered into the raffle to name a fish. So you have to fill out that form every day when you attend the live stream. And I'll say, if you want to fill out the form and have it count, today you have to include the word fish in your submission. Okay, so you can't just fill out the form randomly 4 times. Include fish in your submission, and then I will like tally up all the people who have attended all 4 sessions and raffle it off to someone to name a fish. Okay, cool. Back to the stuff. Oh yeah, if you want to meme my LinkedIn profile, go for that. That would be great. Yeah, no, absolutely. libraries and pandas back in game mode. So libraries are basically just packets of code that other people have written that we can use. We import a library just by saying import and then the name of the library. So random is a really popular library in Python that allows you to generate randomness. Technically, it's not truly random. It's pseudo-random. But one of the basic functionalities it gives you is the random function that will just give you some number between 0 and 1. So if we run this, we import it, and we get a number between 0 and 1, 0.98124, whatever, right? A fun way to get some randomness into our code if we want to like simulate flipping a dice or something. Oh yeah, someone asked, yeah, just put the word fish in the form just so I know that you attended and you heard the secret code word. Yeah. And so usually the way that we access things from libraries is we just import the library and then we do library dot and then the thing we want to use, right? Usually the best way to learn about a library is to look up its documentation, right? So like if I just Google Python random library, this first documentation, it's a little bit dry, but it shows you all the things that are in there, right? There's usually also lots of good sort of explainer tutorials, so lots of things in there. But sometimes there's not documentation. And so if you just want to see everything that is part of a library, you can use the dir utility. So you say dir, opening parens, thing, and then closing parens. But I'd be careful. The output from this is usually pretty, it's usually pretty verbose. So we hit this. There's just a lot of stuff, and a lot of it doesn't even make that much sense. A lot of it's not helpful. But there are some things that are cool. Like it gives us to make a random choice from a list. We have that. Random is one that we used. One of the things we used. Random integer is another one in there. So that dir utility will get you all of the things inside something. Someone asked about what do you mean by pseudo-random? Yeah, so pseudo-random. Okay, you're sidetracking me again, but this is a cool thing to talk about. So if something is random, then there is truly no way to predict what's going to come out of that, right? And like usually our only source of randomness is by like staring at really, really small molecules, right? Like is this radioactive particle going to decay? That is, as far as we know, that is truly random, right? There's no way to actually definitively predict that. Computers don't actually work that way. Computers are, determined, right? And so you'll come up with some function that is really hard to predict, right? So like maybe I would write a function that says, like random number, or in this case, we'll say pseudo random number. And it will just take, it'll take some seed, and we'll say by default that seed is 1. And it'll say return 1 times some large number, and then we'll raise it to then we'll multiply it by 60 or by 52, and then we'll divide it by 2, right? And I run this, and I say pseudo random number, and oh wait, I have to actually do the parentheses to run it. And we get a number, and like that number looks random to me, and like if you didn't know this function, it would be hard to predict. But if you knew this function, you actually could predict it, right? And we can, you can do fun things like chain this together, where we say random number of random number, and you get a different random number. Oh wait, is that actually the same random number? Yeah, I don't know. But that's kind of what pseudo-randomness is it's kind of hard to predict, but if you knew exactly how it was doing what it was doing, you could actually predict it, which has some interesting security implications. But great question, random versus pseudo-random. Someone mentioned you can use time as a seed, and this is actually a great way to get around this. Yeah. So you see I used a seed here, and if I change the seed to, to instead of 1, if I said x is 24, wait, we're giving the same number out. Am I doing something very silly? Oh, wait, I'm saying 1 and not instead of x. Okay, there we go. So we get a different number there. Yeah, that was a silly bug. And you could, instead of 1, you could say, there's another library called time, and you could get the current time as the seed, and that would make it sort of really hard to predict, but still technically not impossible. If you knew what time it was running at and you knew the logic, you could kind of get it. Some would say you're confused. Don't worry about this. This is not a cybersecurity course. This is not a math course. It's a random number generator. That's something that we could talk about if we have like a random chat later. We can talk about pseudo randomness, but for our purposes, doesn't matter. Cool. There's another really helpful library called Matplotlib. That's, I know, a long library name, but there is this one thing inside Matplotlib called pyplot that we use a lot that is super fun and super helpful. But because this is a long name, we will import it and we'll say as PLT, which is basically an alias. We're saying we're taking matplotlib.pyplot, but we're just going to call it PLT. And so that makes our code a little bit cleaner. And this is actually a line that you'll see a lot. It's what's called kind of an idiom in Python, which is just to say this is a common way of importing Matplotlib. So here we could say we have a list of x's and we have a list of x's squared. And then we can just say plt.plot. We give it our x's, we give it our y's, we run it, and boom, we have a little graph, right? It's a nice little graphing functionality. It's simple, it's clean, it's easy to use. So now we get to the big one. As far as I'm concerned, this is really the point of this workshop, is really to get you to the point where we can talk about pandas. Pandas is a really, really big, robust, helpful library that does a ton of data science-y things for us. The way that I would tell you to think about pandas is it kind of works like an Excel spreadsheet for us, right? Any kind of data that you could put into an Excel spreadsheet, we could also put into, wait, why did I say Excel? Anything that you could put into Google Sheets, right? Google Sheets supremacy. Anything you could put into Google Sheets, you could put into a pandas data frame. A data frame is kind of the big object that we use. It's what it's called. So first, we're going to look at how we even create this. So we'll import pandas as PD. Again, that's just creating an alias. I love the Google Sheets love. We love to see it. And one common way that we'll create a data frame is by reading in actually like a CSV comma separated variable data file. So like an actual spreadsheet, we can just read it in. But another way we could do this is we can have a dictionary of lists. And the idea, this is why we had to talk about dictionaries and lists. But the way we think about this is that each of our items in the dictionary is a column. So we have a column called state, and then this list is all of our rows in that column. We have a column called abbreviation, and then these are all of our rows in the column that's titled abbreviation. We have another column called population, and these are all of our rows in the column population. And then we have a column called Starbucks, and these are all the rows in the column called number Starbucks, right? So this is some data that I just gathered, which has some states in the US and some facts about them, their abbreviations, what their current population is, and how many Starbucks they have, which is a common coffee shop that's actually based out of Seattle. And so then to create that data frame, we just say pd.dataframe and we pass in our raw data, right? And boom, we've created a data frame. Now, one really helpful function, once we have a data frame, our data frame is called df for data frame, is we can do .head on it. And this will give us a nice little readout of just sort of the top rows. So this gives us the first 5 rows. So we can see California, the abbreviation is CA, the population is, that big number. That's the number of Starbucks they have. And so this actually shows us what that spreadsheet would kind of look like. Let's see. Oh yeah, no, LibreOffice. Yeah, no, this is the thing. Is like if I'm fighting with Microsoft, like Google things better than Microsoft, Mac OS better than Windows. If you're doing stuff on Linux, like you get to look down on all of us, right? Like we bow down to y'all using Ubuntu. Yeah, I'm definitely here for the LibreOffice supremacy. Okay, someone's bad-mouthing Google Sheets because of losing your internet connection. You don't need an internet connection to use Google Sheets. You can do it locally. This is a thing not many people know, but it's possible. Let's see, other comments. Yeah, no, you're good. You're good. GNU Linux chat in the chat. Yeah, that's true. So this is our little table that we get. This is our spreadsheet, right? And this is going to be really helpful for lots of things. The first kind of thing we're going to learn how to do is just how to get a single column, right? So we can pull a single column out of our data frame just like we would in a dictionary, right? Because remember, each of these are like keys in our dictionary. So if we say df and then we just say number of Starbucks, we get not a list, but something that looks like a list. It's technically what's called a series, but for most purposes, it kind of functions like a list for us. So we just said, give us one column called number of Starbucks, and it gave us just that column, right? And we can see 2821, we can see 1042, super cool. We can also get cool stats on it. So we can do, get the number of Starbucks, and we can get the mean, or we can get the standard deviation. So our mean for number of Starbucks is 854, and our standard deviation is 828. Someone said, I don't think we'll be feeding data in through addictive lists every time. Yeah, no, that's a good point. Is in the future, we're actually going to be getting huge data files that are usually in CSV format, which we can talk about later, and we'll be importing them. It's kind of another step to learn how to import data into Google Colab, but we'll talk about that next time. But yeah, good point. This is not the normal way. There's someone saying addictive lists doesn't make sense. And it is kind of a complex idea, but I'll scroll back up to here. So each column is an item in our dictionary, but that column itself is a list, right? So we are nesting inside of our dictionary. We have a map of the column name to all the data. And then inside all that data, we have a list of each individual row. This is a lot, so I'll give you kind of a second to digest and think about it. This is something we'll kind of come back to. But the important thing is thinking about this like a spreadsheet and saying, okay, if I want to get one column from my spreadsheet, I can just give it the column name in square brackets, and it'll give me back that column. So I think thinking about it more like a spreadsheet and less like a dictionary of lists might be helpful. So we can also say, once we have that column, we can say, give me the mean of all of the values in that column, just with .mean. Easy. We can also say, give me the standard deviation. So we can see here that the average state has 854 Starbucks, but there's a standard deviation of 828. If you are not familiar with standard deviation, it is just a measure of how spread out your numbers are. So if your numbers are all very similar to one another, your standard deviation will be low. If your numbers vary over a really wide range, your numbers will be really different. This is something we can talk a little bit later. We're going to use this actually in our next session, but standard deviation is helpful. We also mentioned this, that each individual column can function like a list, so we can loop through it. So we could say for state in just the column states, and we can print out state is a state in the US. So we get for every state, we say California is the state in the US. Texas is a state in the US. New York is a state in the US. Yada, yada, yada. You get the idea. Also cool, we can use them in graphs. So remember earlier we said we plotted just two lists, but we can get population, and then we can get number of Starbucks, and then we can add some labels. So we just say PLT X label, and we say this is the label we want for the X axis, and we can say Y label and the label we want for the Y axis. And then if we run this, we get a cute little graph with population and number of Starbucks, which I think this is actually kind of a cool graph, right? It's like, it actually kind of suggests that your Starbucks actually increase exponentially with your population, right? So if you add another person, you might get like 3 more Starbucks. Obviously, I wouldn't draw any conclusions from that, but it's kind of neat just to plot some data together. Someone asked, mean and standard deviation are a method of data frames. Yes, and this is something that I would drive home, is the reason we're putting this data in a data frame is because of all of these little helpful tools that the data frame gives us, like mean and standard deviation. Someone said average distance from the average, and that is basically what standard deviation is, or that's at least a very good way of thinking about it, yeah. Someone asked, where did I get the data set from? I literally just Googled that shit and copied and pasted. Yeah. Later, we'll get into better ways of gathering data. That's like what our whole next session is really about, is exploring where do you get data from? How do you clean it up? How do you know what you're looking at? Today, we're just kind of being silly. Another really helpful tool in data frames is the idea of filtering, right? Maybe we only want to look at states that have more than 20 million people. So we're only looking at our really big states. The way that we do this, and this is kind of some funky syntax that we're going to just look at and just kind of see, okay, this is the way it's done. There technically is like a good explanation for why it's this way that we won't get too deep into. But so we can say df population greater than 20 million, and then we place that inside more square brackets. Actually, I said we weren't going to talk about it, but maybe we'll actually talk about it. So if we just take out this inner thing, where we got df, it just tells us for each column, is this thing true or false? It just gives us a list of trues and falses. So it'll say our first thing, it's true that population is greater than 20 million. Our second thing, it's true that population is greater than 20 million. Our third thing, it's true that population is greater than 20 million. And then for everything else, it's false that population is greater than 20 million. And so we can now take this list of trues and falses, and basically we say, just give us every row for which this is true. And we get 3 states. We get California, Texas, and Florida that all have more than 20 million people. And you can look at, you can say, okay, 21 million is greater than 20, 29 million is greater than 20, and 39 million is greater than 20. Let's see. Google engineer telling about how to get data. Yeah, it's just what I do. You know, it's kind of my bag. I'm excited to hear that folks are excited for the next sections. I'm really, really pumped for them. No, I mean, it's, you know, it's Google's thing. I'm here for any shade that you are here to throw. Let's see, got it. Yeah, it is. Someone said, is this a list of Booleans? And that is exactly right. We're giving a list of Booleans, and so we're only getting the rows where that is true. Yes. Yeah, operator overloading. Sets. If we have time, we could talk about sets. I know we're quickly running out of time, so we might not get to that. But there we go. That is how to filter a data frame. Another really helpful thing we can do is we can create new columns, right? So what if we wanted to say, how many Starbucks are there for every person? Or how many people are there for every Starbucks, right? Because there are more people than there are Starbucks. And so we can literally just say population divided by number of Starbucks. And that'll just go through for every row. It'll say, what's your population? What's your number of Starbucks? Divide population by Starbucks. And then put it in the same row in a new column called people per Starbucks. And this is the thing, I think this is like a really kind of clean way of writing this sentiment, right? I want to take whatever the population, divide it by whatever the number of Starbucks, and then assign that to a new column called people per Starbucks. We can print that out and we get people per Starbucks. Incredible. Let's see. Someone asks, double brackets converts it. If we're talking about this up here, yes, we're kind of giving a new kind of index. So instead of saying, give us the column name fit this thing, we're just saying, give us all the rows for which this is true. But yeah, the double brackets kind of convert that into the actual data frame is a way of thinking about it. Someone said, what library framework are we going to use later? We're actually not using TensorFlow. I like TensorFlow, but I think it takes actually like a while to fully appreciate what's cool about TensorFlow. We're going to be using scikit-learn, which I think often gets sort of undersold. Scikit-learn is very, very powerful, and we're gonna play around with that a lot. Someone said data filtering is subjecting the data to a bunch of conditions so that we can draw an inference from that data. Yeah, I think that's a good way of thinking about it. That we want to just we want to kind of ask a very specific question of our data, and filtering allows us to do that. Yeah. I'm glad it's not PyTorch. Hey, I haven't used PyTorch that much, but it seems fine. They have a cute logo. Let's look up the PyTorch logo. Oh, I'm really getting off topic. See, that's oh wait, it used to be way cuter. Yeah, okay, that's the PyTorch logo that I remember. That's a cute logo. This new PyTorch logo, I'm not here for it. Okay, we only have a few cells left, so we're really on the home stretch here. Y'all are really, really doing brilliantly. I am loving all the engagement and all of the input. Someone said the TensorFlow logo is superior. It is, but I am not going to get into that because we have 9 minutes left. Okay, so we assigned a new column and we defined it as people per Starbucks. So that's kind of cool, right? So now we could say, what if we just want to analyze states that have a Starbucks for every 30,000 people or fewer? Now, this is the one kind of gotcha that I'm going to throw at you here. Data frames are powerful. Sometimes they can be a little bit unintuitive. So when we do a filtering operation like this, we actually don't get a copy of this data frame. We get what is called a view into this data frame. This is kind of a complicated concept, but the idea is this is not a new data frame. This is just a reference to the old filtered data frame. And so if we try to create a new column on this, when we're trying to copy it, we're going to get issues.
So if we hit run here, we'll get this error that says a value is trying to be set on a copy of a slice. We don't need to get into too deeply why this is. There are some good explainers of this that I could link to. But basically the idea is that Pandas wants to be efficient. So it doesn't copy all the data over when you filter it. It just gives you a view into the original data. And normally this is great because it means Pandas can run really fast. And it's not constantly copying data. But if we want to start messing around with a new data frame, we want a fresh copy of that data. And it is really easy to get that fresh copy just after we filter. We just want to say .copy on the end. This says, this is an old data frame. I want a new fresh copy just based on this filtering, and it will give it to us. This is one gotcha that we're going to play with a little bit. This is like the one Pandas bug. Well, it's not really a bug, but it's the one thing that'll come up for people sometimes. So if you get this kind of error, normally you want to throw a .copy at the end of some filtering operation. And so now we could say the value caffeinated equals highly, and it'll work for us. And boom, there we go. We have all this, and we have our new column, highly caffeinated. Let's see. Indexes to an already existing created data frame. Yeah, that's exactly right. That if you don't create a copy, it is just going back to that original data frame, and you don't want to change when you just have a reference of it, right? So it's saying, hey, you're doing something weird, you're changing it, but this isn't its own data. This is just a reference of the old data, so this is probably an issue. Incredible. Okay, so we have 7 minutes left. I have another section that is like a bonus round of my favorite things. It's like a lot of cool stuff. I'm gonna actually see if I can talk to Mary really quickly and see how bad is it if I go over. Actually, maybe I should just check to see if there's something on the schedule right after this. Does anyone have the schedule up? Oh no, yeah, you're welcome to dox me. I don't do a lot on Twitter. I just have like old tweets from like high school, so you can go and cringe at that. Let's see. I said 7 p.m. is the next one. I guess is that. Okay, cool. So we actually do have like another minute if we wanted to. We can go over. This is great. Okay, we can hang out, we can chat, and we don't have to rush. So I will say at this point, like the really important things in order to be set up for the rest of the course, we have done them. I want you to get up and I want you to give yourself a hug because you really stuck it out and you did some good stuff. We are going to go for a bonus round of some stuff that I just think is really cool about Python. Let's see. What are you most active on if someone wants to reach out? Yeah, I'm actually pretty active on Insta. You will mostly just see things. You see videos of me making coffee is like the biggest thing. But also I take some photos and stuff. I thought I should try to be more active on Twitter, but it has not happened yet. LinkedIn, I try to do that. I should be, if you look right here, I should be on most platforms at WLifford. I technically think I have a YouTube channel that I posted a couple videos to. So if you want to go find that, you're welcome to. So yeah, it should be at WLifford like everywhere. Okay. Someone asked how much I spend on coffee per week. This is a great question, and I will not answer it because I would be malpractice for promoting my my coffee mini event. Come to the coffee mini event. We're going to talk all about, like, I'm going to have every single way I make coffee, and we're going to talk about, like, how much are you willing to spend on coffee? How much hassle do you want to spend on coffee? And what is, like, the right coffee thing for you? So yes, come to that event. It'll be great. I'll drop the link to it. And actually, maybe before we do the bonus round of my favorite things, I will sort of like wrap up and kind of send some extra links your way. So I think I already sent this one out. Okay, so I'll wrap up and then we'll do favorite things as a bonus round. So that kind of is the core content. If you have never used Python before today, like really well done. Give yourself a pat on the back. If you feel like that moved really fast, that is because it did. We were cramming a lot of content in there. But I will say that if you are still trying to grasp some of these things, there are a couple really big things that I would push your way. One, you have access to this notebook. Please use it and abuse it. Play around with it. I think one of the best ways to learn is to break things and then try to fix them in a new way. So play around with the notebook. Second, if you have any specific questions of like, hey, you didn't fully explain this, or this was kind of complicated, go back to this form. This is the form that I'll be checking just personally for feedback or for questions on this. Specifically, if a lot of people ask the same question, I will cover it at the next session just to be sure we get through, like things that people didn't quite get. Also, if you just want to say, hey, if you want to, just get on my radar, drop a line. Also, if you want to be in our competition, you have to attend every single one of these events, every single one of my sessions, and send a form in that says the word fish in the description or in your message. And then you'll be entered into the raffle to name one of my fish. The other way you can win a fish name is by creating the best meme for this meta track and posting on the Discord. And then the third way is by winning the competition that we'll announce at the next event. So stay tuned for that. And then finally, if you are still trying to learn things, one great resource is that tomorrow there is another intro to Python session being done. It'll be explained by a different coach, not me. And sometimes that can be helpful to hear something in sort of a different way. So that could be kind of a good kind of additional refresher. Thank you for the kind words, everyone. I'm glad that you felt like that was well explained. I believe Python is the next language taught. Yeah, I would love if people got more into Python. Someone's asking if we could do more challenges with data frames. That's a great thought. We'll definitely get more into data frames in next session. But maybe I can drop a link to some interesting resources there. Yeah, I did give a TED talk back in the day on morality and artificial intelligence and language. It's good. It's old now, but you can go check it out. There's the link. There's the GCal with all of the live sessions. Incredible. Come to light no light at 7 p.m. Other housekeeping announcements before we go into my favorite things bonus round. I mentioned my Hack Your Espresso mini event. This is probably my favorite thing that I'm doing all week. We are specifically going to be talking about different ways of making coffee, some of which are a lot easier to get into. I think at previous ones, I've just been like espresso. But not everybody has an espresso machine, and there are really great ways to make great tasting coffee without spending $300 on an espresso machine. So that's what we'll be talking about at that session. And then probably the biggest link, the biggest, most important thing is you should come to the next session of this track, which we will be covering using the tools we've learned today to actually explore real data. I may have committed some very, very minor crimes to get you some very, very good data. And so if you did not show up, I would be very sad. I've gotten some really, really good real estate data for us to play with, and that'll be a blast. And it really builds off of what we did here today. So make sure that you sign up for that the next session in this track. Someone asked what time is the coffee session again. I believe it is 4 p.m. No, it's not. It's 10. Yes, it's 10 a.m. Pacific time, which I guess would mean it would be 1 p.m. Eastern time, if I can do time zones correctly, which I'm pretty sure I can't. Incredible. Okay, let's do the bonus round. Some of my favorite Python things. So these are some things that you can do in other languages, but are really fun to do in Python. So one thing that's just really easy and delightful in Python is doing exponents, right? Like raising something to the power of 3 or squaring something, or even taking the square root of something, right? So if we have a number x equal to 9, we can take x squared just by saying x times 2, which I think is actually really great syntax, right? Because we're kind of like multiplying the multiplication of it, right? We can also do x square root by saying x times 0.5, because if you remember your early math classes, or maybe your late math classes, I don't know, a square root really is just raising it to the power of 1/2. And so we could say, okay, we get 81 when we square it, and we get 3 when we take the square root, which is what we would expect. Exponents in Python, a dream. Let's see. Interview prep and DSA. Y'all, I love talking about technical interviewing. I'm not doing a technical interviewing session this week, but would hope to do one very soon because that shit's fun. which I know makes me weird that I enjoy interviewing. But I guess it's more fun now that I'm on the other side and I get to ask the questions rather than answering the questions. Someone asked if the caret symbol works. It does not. The caret symbol in Python actually, I think, is the exclusive OR symbol, but it's used in weird contexts. So no, yeah, the caret symbol does not do exponents. You just do times times or asterisk asterisk, and that lets you do exponents. Exponents, really fun. Oh, okay. Someone's asking again about like internship journey and stuff. And actually, I will talk about that at the end of this once I get through with this because multiple people asked, and it's fun to talk about. So list comprehensions are another one of my favorite things in Python. So we've done this a couple times where we have a list and we iterate through it and we build up some new list, right? So this is the dumb old way of doing this, where we have for number in numbers, and then we do number squared. We do number squared, and then we append that to our new list, right? And this works fine. Wait, Hannah, what bad word did I say? I'm really trying to be better this time. I think I've given myself like one curse word every session, but I usually don't make it. I'll try to keep the language clean. I'm sorry, there are children present. So this is the old way, and it works fine, but there is a much cooler way to do it in Python, and it is called a comprehension. And this is because it's a really common pattern to have a list of things and want to transform that into another list of things that have a relationship, right? And so this is basically a condensed way of doing a for loop. And so we say for number in numbers, we're just getting number squared. So what took us 3 lines here now is only taking us a single line. And I think it really expresses it in this kind of concise, elegant way. So something that people love in Python is comprehensions. Another important note is that comprehensions are inherently functional and inherently very safe. And the reason this is because remember earlier we were talking about how, if you edit your list in the middle of your for loop, you could get into an infinite loop where you could break things. It's impossible to do that in a list comprehension because you're just saying, I have a list of inputs and I'm getting some outputs. So list comprehensions, very cool, very fun. If I see someone use a list comprehension in an interview, I'm like, hey, you know what you're doing. That's neat. List comprehensions do make you hip, yeah. Another fun thing, this is one that actually just a couple months ago I realized was a feature that got added to Python. You can chain comparisons. So in most programming languages, if you want to do like a comparison with 2 points to see if it's between 2 things, you have to do it like this. So for example, in the US, you can drive once you turn 16, but you can't drink until you turn 21, right? So if I wanted to say, can you drive but not drink? I'd have to say, is your age greater than 16? And separately, is your age less than 21, right? And then I can print that out. But in Python, you can chain them together kind of in a normal, natural math way. And you could say if age is greater than 16 and less than 21. So both of those work. But this one is kind of neat because you chain it together. Incredible. Do we still need to declare number squared in the cool way separately? This is a good question. Scrolling back, we're defining the new list right here. And so we don't have to separately say, like you don't have to say, right? That wouldn't hurt anything, but like here we have to create this list first and then append to it. But here we don't even need to create the list first because this statement creates our list for us. Yeah, jumping back there. Okay, yeah. So someone's asking, what is the use of the square brackets here? And the answer is it's what we call syntactic sugar. It's just something that someone came up with that said, hey, what if you have for inside 2 square brackets? What if we made this a list comprehension, right? So it is technically kind of a new usage of the square brackets, but it just signals to us that we're using a list comprehension. And it is obviously related to defining a list. And so I think there's some natural, like it kind of makes sense to me there. Okay, yeah, so to repeat the cool way. So the old way, the stupid way, stupid, that's not a bad word. I'm allowed to say that. We have numbers squared, then we iterate through our first list. So we're just trying to get all of these numbers, get the square of them, right? These numbers times themselves. And so the old way, we cycle through each of those numbers, and then we square those numbers. I mean, you could even break it up even more and say number squared. Oh, my indentation is off. And then we could say numbered squared append. That makes it maybe even a little bit clearer. What we're doing is we're taking each number, we're squaring it, then we're appending that to our empty list here. So the cooler way is you can say whatever the transformation is, if it's squaring, we can just say number for number in numbers. And then this becomes our new list. So this says to Python, for all the numbers in numbers, do this operation, and this is the new element in the new list. So if we can also print out numbers. And so this is what the comprehension did, is it takes this and it squares it and it gets 1. It takes this, it squares it and it gets 4. It takes this, it squares it and gets 9. So comprehensions, they're a little bit funky. They take a second to get used to, but I'm a big fan of them. I think once you get used to them, you can kind of see some value in them and they feel really elegant. Let's see. So he said, it looks like I'm mad at someone when I'm typing seriously. Damn. Okay. Dang. Oh, I said something bad. Okay. Dang. Yeah, I don't know. All I can say is I'm not mad. I like typing, but I type seriously. That's true. Someone said, what if we drop the square brackets? So it should fail in that scenario. It should probably give you like a syntax error. Yeah, syntax error. We need those because normally for number in numbers should only be on its own line to start a for loop. And the only way we get around that and signaling that we're doing a list comprehension is by adding those square brackets. Let's see. You can only use the cool way for one operation. Yes, that is a really great point. Is if we wanted to do like what if we wanted to do numbers squared and numbers rooted? Like in here, we could say number squared equals that, and then number rooted equals number to the power of 1/2. And then separately, we could say numbers rooted append number rooted. This is getting a little bit complicated, so I don't want to dive too deep in this. And so that would give us numbers rooted, but we could also always just come up with our own comprehension where we say numbers rooted but cooler, and say number to the power of 1/2 for number in numbers. And if we said numbers rooted but cooler, it looks like what we would hope for. Actually, is that what we would hope for? That doesn't. Oh, okay. No, we need to put in some parentheses. Pandas, y'all. We need to use pandas. Okay, there we go. Now we actually get the roots. Yeah. A number is a variable here, like for number in numbers. Yes, this is a great point to throw out, is that like this really is a tiny little for loop, right? Number is our dummy variable, just like number is our dummy variable here in the original for loop. We're just compressing it onto a single line. Yeah. So really a list comprehension is just a way of compressing a particular kind of for loop into one line. Let's see. The AND operator is automatically assigned in the second statement in the age condition. Okay. In the age condition is automatically assigned in the second if statement. Yes. Yes. This is a good way of thinking about it, is that we're saying in this chaining scenario, we're saying this has to be true and that has to be true, which if you're like doing just math and writing things down, that's kind of the natural way that people think about it. But Python can kind of read it that way too, which is nice. Someone said it's kind of like a Lambda function. Yes. Lambda functions didn't make my list of favorite things, but Lambda functions are pretty cool too. Oh yeah, I'm glad that you like the TED Talk. Yeah, we can talk more about that if you want. Okay, the last favorite thing for this session, and then we could just chat and do more Q&A and stuff, is the example of doing both of them in once is technically true. It's a little bit what's the word? It's very dense. So it does work. Yeah. So the last thing that we'll cover in the list of my favorite things is negative indexing. So remember, we talked about, I'll actually get rid of this for now, comment that out. We talked about how you can, if you have a list, you can index starting at 0, right? So this will be first, and you can do 1 and you would get second, right? But sometimes we just know we want one from the end, right? And that is where we can use negative ordinals. And we can say, okay, give me the one at the very end. And you can just say -1. Or you could say, give me the 1, 2 from the end. And that'll give us the end, 1, 2. Which I just think is so delightful and so cool that that is a feature in Python. And thus concludes some of my favorite things in Python. That is all the content that I had. And so now we will talk about all the things that I told people, hey, save that for the end. That's a cool thought. So one thing that people asked about a couple of times was like, what is my journey? What is my job now? How did that all work? And so I will hopefully quickly try to run through, kind of all the stuff that I've done, which is still, pretty short career, thankfully. So I went to college at the University of Tennessee. Oh, hi, Adam. Welcome to the stream. It's good to see you, buddy. And I actually started in college as a mechanical engineer, and I stayed a mechanical engineer for 2 years. But that summer of my freshman year, a couple of things happened. One is I was trying to get rich quick, right? As a lot of people try to do. And one thing I was like, okay, I can build people simple WordPress sites, and I needed to find customers. And so I got the business directory of my small town, and I sent out 300 letters to local businesses saying like, hey, I will build you a website for like $100, right? And most of them did not respond, but one person responded. And she was like, hey, I want a website for $100, like meet up with me. And I met up with her at a library, and she took out of her purse a $100 bill, and she's like, build me a website, Will. And I was like, hell yeah, I'm into it. I'll do it. And there were a couple other things where I realized, even though in class I was doing mechanical engineering, everything I was doing in my free time was more computer science based, right? And I was like, dang, maybe this is a sign that I should switch. And so I ended up switching to computer science and kind of getting a late start. But then I had this internship at a local startup accelerator called KEC, which was super, super helpful. It was unpaid, but it like let me meet a lot of people sort of in the city of Knoxville, where I went to school. It was unpaid, but then later I ended up actually getting through the people that I met there a deal with the city of Knoxville, a contract to build them a website, which was really fun. And so the internship was unpaid, but it set me up with a lot of experiences to actually make some money later, and that was awesome. Fast forward to sort of my second to last year, I actually switched my major from computer science to this program at my school called it's called College Scholars, but it's kind of the make your own major. Because I knew that I liked computer science, but I really liked talking about other things too, like linguistics and philosophy and economics. And I was like, I don't know, I think there's like a lot of cool intersections here. And so I had a major that I proposed that was titled Machine Learning and the Ethics of Automation. Was kind of the flashy buzzword, but it basically was looking at sort of the morality surrounding the way that we build sort of artificially intelligent systems. That's actually exactly what the TED Talk is about. I think someone dropped that link in there, but that was kind of the core of that major. And actually, a year after I started that major, kind of my last summer, my junior summer, I did an internship at Google. The process for getting that internship was like wild. We really take our time doing interviews and recruiting at Google. But I had originally a goal of every day I'm going to apply to 4 internships, right? And so I had a giant spreadsheet where every day I just spammed my resume to 4 different companies. And I ended up actually applying to like I think over 100 internships that fall, getting ready for the next summer. And kind of went through this process where I would interview a lot, and I would get an offer, and I would ask them for an extension basically until I heard back from the next person, right? And so I kind of ended up chaining together, got an offer from one company that I thought like, hey, this is cool, but if I get an offer from that next company, like I might want that better. And so I say, hey, I love this offer. Can you give me like 3 more weeks to decide? And then three weeks later, I got an offer from the next place. And I told the first place, hey, it is a great offer. I think I'm going to do something else, right? And so then for the next company, I said, hey, this is a great offer. Can you give me 3 more weeks to decide? And 3 weeks later, I got another offer from a company that I thought would be a little bit cooler, a little bit more exciting. And then that kind of ended finally. It was like I applied everywhere by like November, and then it was like the middle of February that I actually heard back from Google that I got an internship. So I interned actually in Pittsburgh at the Google office there, and I worked on Google Shopping. I also, upgrades. That's what we're talking about. I actually fully recommend this strategy of apply to a lot of places, and then always make sure you have one offer open, right? And some people will say like, hey, isn't that kind of like skeevy to keep an offer open until you get the next best offer? And I would say I really don't think it is. I think that companies are playing this game with you, right? And it's just the understood way that this happens. Is companies kind of want to get you to accept as soon as you can, and it's in your best interest to take as much time to wait and decide as you can. And so I think it's actually really good to ask for extensions when you can. I've never had a recruiter ever say no when I asked for an extension. So I think that is a really good strategy to use. So I interned at Google in Pittsburgh on Google Shopping. And then actually that fall interned at Amazon. I got an offer from Amazon, but wanted to work at Google more than Amazon. But I still thought, hey, it could be cool to work at Amazon, specifically because Amazon said, hey, we'll let you work on Alexa because we think that's a thing that you're into. And I was like, dang, Alexa does seem really cool. So that fall, I did a fall internship at Amazon in Boston, working on the Alexa team. And that was actually a really cool experience. I know a lot of people do have really negative experiences at Amazon. I also know a lot of people have a good time there. There's also like the concept of working at a large tech company is like a really, really complex, nuanced moral proposition that I think is like really good to take seriously and think about. But I really enjoyed that internship and I learned a lot. And it was like really cool to think about language and machine learning and artificial intelligence and all these things together. So I really liked that. And then what happened with the Google internship is at the end of your Google internship, if you do well, they give you a chance to do what's called a conversion. And basically, you do 2 interviews to get the internship, and they let you do 2 more interviews. And if those go well, then they'll give you a full-time job. And that's what happened for me. Is I did that Google internship, and then did well enough. Thank you to my host, Adrian. Adrian was a blast. If you're out there, Adrian, thank you for being my intern host. And then got that return offer. And when I got the return offer, they said, hey, where would you like to work? And I actually had a long time ago spent some time in Seattle. And I said, I actually love the city of Seattle. Can you put me there? And they said, yes, we have a lot of teams that are looking for new people in Seattle. And so that's where I ended up. And the current team that I joined is called, we do cloud competitive benchmarking. And sort of the simplest way that I have to describe this is that we run a bunch of things, or a bunch of programs on Google's cloud and other companies' clouds, and then we compare the results to see this is what we're really good at and this is what we can improve on. I could talk more about my work if you're interested, but it gets kind of dense and nerdy really quickly. And so that is kind of the long and the short there. Someone asked, what do companies like Google look for in interns? So this is actually a really great question, and it's something that I have actually some insight on. So largely we think about like smaller companies transitioning into larger companies. And from what I understood and what I saw when I was applying to a lot of internships is that really small local companies will totally talk to you and totally give you the time of day and work with you. And actually really large companies, because their first layer is always just do some coding challenges, they will give you the chance to do that coding challenge pretty easily too. In my experience, it's actually the mid-sized companies that will be like exclusive based on school, right? So like I did not go to a particularly prestigious college. Like I love UT, but it doesn't have a super strong name brand. And I actually do think that at some medium-sized companies, they saw my resume and they saw UT and they were like, we're not interested. But a lot of large companies like Microsoft and Google and Amazon, they just said, we need a lot of people. We will give you a shot to do the interview process. And so from there, it just was a process of being really good at technical interviews, which is a really specific skill to learn, right? I think a lot of times we imagine that being a good interviewer means you're a good engineer, but these things are not the same. Interview questions are much more often like really deep into algorithms and running time complexity. And these are not things that come up every day in being a software engineer. So learning how to interview better is like a really, really big thing. I actually would love to talk more about that if we have more time later, because there's like lots of tips there. Yeah, someone asked, what does it take to do an international internship? I don't know as much about this, but the one thing that I do know is that the larger the company, the more resources they're going to have to devote to specifically getting people work permits. So I know smaller companies might not have they might not have a person whose job it is to help people deal with international work permit situations, which I know are just like a massive hassle. And so that's like the one piece of advice that I have is that larger companies are usually going to go for or usually going to be able to give people more support to do stuff internationally, and small companies often just won't have the bandwidth for that. Let's see. Someone is preparing to get into Amazon as a security professional. That's cool. Cybersecurity is super important. I see PPO as an acronym. I don't know what that means. I see GCP as an acronym. I like Google Cloud. That's what I work for. Any tips for Googling online coding challenge for sophomores? I have mine on 14, and I will probably mess it up. I'm not expecting anything. Yeah, actually, here's one piece of advice I'll give. Also, maybe I'll make my face big now because we're not looking at code anymore. One piece of advice that I will give is two of the bigger coding challenge sites out there are LeetCode and HackerRank. In my experience, LeetCode is just really hard, right? Like there are like 3 easy challenges on LeetCode, and then all of them get very challenging very quickly. In my experience, especially if you are currently a student or a new grad, HackerRank just has a lot more sort of like entry-level questions, and they're honestly more like the questions that you will see in interviews for internships or for new grad internships. If you're a lead engineer that has been working for 10 years in industry, yeah, you're going to get some hard like LeetCode style questions. But in my experience, LeetCode just kind of like bummed me out. Like there are really good, helpful questions on LeetCode. But in my experience, just consistency of like every day. For me, I said like for 2 months, I said every day I'm going to do at least 2 HackerRank challenges. And there were always ones that were like still challenged me, but did not feel like dang, I don't know how to do this. So that's my take on the best place for a challenge. I think it's good to go do LeetCode challenges because if you can do those, then you can probably ace your interview. The other big thing I'll throw out about interviewing is that usually the question is supposed to be relatively simple, and usually the thing that allows you to succeed or not succeed is how well you're communicating, right? I think this is one of the biggest things for me is if a candidate is talking through their process with me, then I can see where they're going, I can see what they're doing, and that usually allows me to give them pretty positive feedback. Sometimes they'll just like think about it and then plop down an answer, and I'm like, this actually didn't help me get a read, and like that might be the right answer, but it's gonna be tough for me to give you kind of like all the full marks because you didn't communicate during the process. So that's something I'd say. Good books to help interviewing for beginners. Yeah, absolutely. Cracking the Coding Interview. It's the Bible. It's the one. I will send a link to that. Cracking the Coding Interview. I would read that book sort of cover to cover. That is one of the things that I did, and it was super helpful. Let's see. Hacker Earth. I've heard good things about Hacker Earth too. Yeah. Cool. How do I make myself a competitive candidate in machine learning and data science as an undergrad? Heard most companies prefer experienced engineers, master's, PhD guys. Yeah, absolutely. I actually can really relate to this. I know that like Google, it is the case that like a lot of the cool machine learning stuff gets is usually like they're looking for people with PhDs specific to that problem for that work. This is the big recommendation that I would give, and this is something that sometimes it's hard to control. But at companies that do machine learning stuff, usually what you will have is you will have some scientists, and they'll have PhDs, but then you will also have a team around those scientists that are engineers, right? And this is actually how I ended up getting to work on Alexa. That I was actually on a team that did software engineering, but I was like, hey, y'all, I love like linguistics and I love artificial intelligence. And so I actually, during the course of that internship, got to talk more with scientists and got to get more involved with like more sciencey stuff and more machine learning stuff because my team touched that, right? So that's like my big recommendation is, unless you're going to go get a PhD, in which case, good, like go get a PhD, that's awesome. Make yourself as good of an engineer as you can, get experience with machine learning stuff, and then look for teams that are adjacent to machine learning And that can be a really easy way to get more experience and get to touch that stuff. Someone said, do ratings matter on coding platforms? If this is like having like a lot of points on HackerRank or LeetCode, I know that some companies use those things. I think most don't. I don't think most companies really care about that. But yeah, that's that. Is there a team at Google in Seattle for Android? That's a good question. I think there is. There are lots of different campuses in Seattle. So I work at the campus that's in South Lake Union, kind of downtown, and that's a lot of cloud stuff. It's mostly cloud. There's also across Lake Washington in a sort of suburb called Fremont, not Fremont. There's another suburb called Fremont, but in a suburb called Kirkland, there's another big office. And I know in that office, they do a lot of Android. They do like a lot of Android apps as well. I think they have some like geo, so like Google Maps and stuff. Yeah. Okay, cool. Well, it seems like the rate of questions is slowing down, and we have gone 30 minutes over. But I'm just absolutely tickled pink that 64 of y'all have stuck it out and come to hang out all this time with me. Let's see. Oh, we have another specific question. I think I've seen this one a couple times, so I will actually answer this and maybe the next one, and then maybe try to wrap it up. So interviewing with Python and the data structures and algorithms part and guide the resources. I've been struggling to find good resources there, and I'm forced to learn Java. Yeah, so I think Python is the best language to interview in. I am biased because when I only interview people in Python. So at Google, your recruiter will be like, hey, what do you want to interview in? And if you say Python, if you don't say Python, you will never get me as an interviewer, right? I only interview people in Python. And maybe I can ask a follow-up question is specifically, is it like preparing for interviews in Python is the tricky thing? And if that is the case, sort of the two things that I would say, one is on most of these sort of coding problems websites like HackerRank and LeetCode, you can pick the language you want to work in. And so, pick Python and just do a lot of those challenges in Python. The other thing is there's a book that I love. It's called the Python Cookbook. Python Cookbook, Recipes for Mastering Python 3. I'll drop just the Google search that I searched there. And it includes a lot of really, really cool sort of intermediate to advanced Python ideas. So like stuff that we had in the My Favorite Things, those are the kinds of things that you find in the Python Cookbook that are not the obvious, like, here's how to loop through a list, but like, oh, list comprehensions or like exponents or, list generators. And I think that a lot of things that will like impress interviewers and it will give you like really good thoughts about how to tackle harder problems, you can find in that book, the Python Cookbook. So that's one that I would recommend. The other thing is I would say that in a lot of cases, the algorithm should be kind of generalizable, right? So we talked about like hash maps are a big thing that pop up in every language. The Python dictionary is a hash map, right? There might be, like list sorting algorithms. And it's like, oh, there are list sorting algorithms in Python. And so a lot of times it's more about understanding the idea and then figuring out how to build it in that other language. Someone asked, isn't Python slower for execution? The answer is like yes and no. I mean, like, yes, there are lots of tasks. Actually, when I was in college, I did a fun code off with a friend where usually the thing you say is that Python is really fast to code in but slow to run, and other languages like C are fast to run but slow to code in. And so we had a code off where the idea was we both got a programming challenge, and then we timed how long it took us to write our solution, and then we ran our solution on a very large data set, and we calculated how long it took to run, and then we multiplied those two numbers together. And so it did take me I think half the time to write the solution, and then it took me about double the time to run it, right? So certain problems work harder or easier in Python. I think in most cases, it is fast enough that for most of the problems you want to solve, it's not worth worrying about. You have to get a very specific kind of problem that really demands a particular kind of performance, where you're like, oh, it matters that I use another language, right? Someone said use Julia. I'm not familiar with Julia, but my sister's name is Julia, so I guess I'm inclined to like it. Okay. Good open source projects to start on. Dang, this is actually one that I often feel like I should do more open source work. But the thing that I will say is that don't go looking for an open source project. Go looking for open source products that you love. And so the couple things that I would throw out is if you use a lot of Python, every Python library is an open, or most Python libraries are open source projects, right? So if there's a library that you really, really like, learn a lot about that library, use it a lot, and then be like, hey, could I make this better at all? And then go and find the community after you have some of that experience. The other thing is like products. So there is a window manager called Amethyst that I use that I really, really like, that allows me to rearrange my my windows. And I have not contributed to that project, but I do occasionally comment on issues and bugs in that project because I care about it and I want to like help it be good, you know? So that's another tip for finding a product you like that is open source and then going and trying to help. The other thing that I know less about this method is like, you can just go looking around on GitHub. I think there was a tag that's like, this is a list of great open source projects to sort of cut your teeth on, right? I'm sure even just Googling for that, you could probably find a list. I think that's a little bit harder to start on a project or start helping on a project where you don't already care about it, which is why I always recommend, the first timers tag. If you look for the first timers tag, you can find like easy things to work on. And that can totally work. I know a lot of people that do a lot of good work that way. But my first recommendation is think about, are there products that you already use and know a lot about that you can then actually go help on because you already care about them and you already understand them. Good stuff. Oh yeah, totally go talk to Canal. Yeah. Or go watch Canal. Yeah. Cool. Any ideas for what to do after following your local Hack Day build track? This is a great question, and I'm glad you asked it now because I'm going to make sure that at the end of this, I have some like good next steps you can take. Most of my advice is going to be, once you have these skills, try to find another cool problem that you want to work on and try to build something for that. But I'll try to put some more meat on the bones there and be a little bit more specific. But that's a great question. And hopefully by the end of this track, it'll be a little bit more clear what you could do. Oh yeah, using GitHub is kind of a hassle. My immediate answer is like, no, you every time you need to use GitHub, you like relearn the 3 commands, you know? I shouldn't say that. Inside Google, we use a different system called Piper that's kind of like Git, but it's different. So I am not the best GitHub power user. There are some, like I think that Codecademy has a GitHub course. I think doing a couple of those things are good so that you can at least know what to search for, right? You can at least know, oh, I accidentally committed something. How do I undo a commit or whatever? Udemy probably also has good ones, but yeah. Yes. Get cracking. Adam's back. Welcome back, Adam. Another question about data structures and algorithms in Python. So I dropped in the book, the Python cookbook, that does have some stuff that touches on data structures and algorithms. I think that there's a book, I think it's actually literally titled Data Structures and Algorithms in Python. That is like, it's a textbook, but it is good. I can drop the link to that book if you're interested. And it's probably worth it. But beyond that, it's a good question. I think I'd come back to the learning algorithms in whatever language you have resources for, and then trying to generalize them. Like I'll say, I actually only ever studied data structures and algorithms in C++, because that's what I went to school with, and then kind of had to translate that in my head to Python later. I think that it was a good thing to do because Python is a much easier language to interview in. The other thing, I have one more thought. HackerRank, coming back to HackerRank, they have discussion boards where you can find a question, and then you can in that question see how other people solved it. And that is actually how I think I learned a lot of things. So go set your language to Python, and then see what other people have done for those hard questions. So there's like an Amazon link to the data structures and algorithms in Python, which is, again, one of those like Bibles. I would recommend that definitely in conjunction with cracking the coding interview. Am I coming to Blaha Gang after this? Yeah, I'll pop in. Yeah, I'm gonna take a break and eat something because I've been going we've all been going for 2.5 hours now. But yeah, should I have to learn it in another language for interviews? Okay, so someone asking about, hey, I know DSA in C and C++. Should I learn another language for interviews? And I am really, this is actually one that I'm really torn on. I will say that if you really like lower level things, like if you want to get into programming operating systems, then most of your interviews probably will be in C or C++. Like they'll ask you to interview in C or C++, and that's great, right? I will say most of the things that I am interested in, like machine learning, like web development, these things, C is less relevant to those things, and so it's more likely that you're going to be asked to interview in one of those higher level languages. I also think in general, those higher level languages are easier to quickly answer questions in, right? You do a lot of reinventing the wheel in like C and C++. I guess C++ is better. You can, if you really can work that, like templating and stuff, like you can do things quickly enough in C++. I think the ultimate answer is if they let you pick the language you're most comfortable in, right? You shouldn't pick Python just because I said pick Python. If you don't like Python or don't know Python that well, I will say it probably is useful to learn some Python and get good at interviewing in it, because I think it is a really easy language to interview in. Linux has been turning to Rust. Yeah, I actually really like Rust. I think Rust is really cool. Okay, cool. Someone asked I think they were asking how common that book is. I don't think it's like the most common ever. I think there is a free PDF version of that floating around on the internet. I paged through that before I interviewed, and I thought it was helpful. So maybe you can find that free version on the internet too. I don't know. Okay, cool. I am now probably going to have to call it. This has been an absolute blast. I will drop a few more links, just repeating them. If you have questions or you want to be in the running to name one of my fish, fill out this form. If you want to be in the running to name a fish, put the word fish in there. Otherwise, if you want to connect with me, I'm at Will Liffert on the internet. Instagram, I'm active on Instagram. I'm on LinkedIn if you want to do that as well. And then probably the other two most important things, I'm doing this coffee session on Tuesday. And then the really big one is on Wednesday. We have the next session of this track that I will drop the link for that as well. So thank you so much for being here. Y'all were incredible. The questions were incredible. Y'all, I had a blast, and I'm really, really looking forward to the next sessions. I will play you out on Kalimba. All right. Thank you so much. Thank you for commenting on my mushroom lights. They are from IKEA. Would recommend. I will try to tune into light. Absolutely. And it's called a Kalimba with a K. Thank you for dropping that. All right. Thank you so much. I had a blast. I will see you all very, very soon. Take care. Happy hacking, y'all. Bye.